Hello, and welcome
Hello.
to...
Wow.
Wait, what? Welcome to
Oh,
this Python 3.11 release stream. Are you listening on the other screen or something, Pablo? What was that?
no, it's just me.
Oh, okay. Hi, I'm Lemon. I'm one of the founders of Python Discord, and I'm here to sort of keep the show moving, listen to you folk, and then learn a lot about the new release. And with me, oh wait, and also, this is my stupid hat.
Nice. Yeah, it's a requirement to have a stupid hat in the release.
Yeah.
Nice one.
With me, I have Pablo Galindo. And why don't you introduce yourself?
Hello, I'm Pablo Galindo, and this is my stupid hat that will change how long I'm doing the release. So I'm Pablo Galindo. I'm the release manager of Python 3.10 and 3.11. Also, I'm in the steering council and in a bunch of other things in the Python community. But for now, the important thing is I do the release and the mistakes, hopefully not too many. So hello, everyone.
And then you're going to be doing the release right here and now, like as we are going to go through this talk.
Like now.
You'll be sitting there and crunching out the release while we talk about what's in it, right?
That's it. I will be sorting all problems as we do. So we will explain a bit what we like, how the release is done, and what you're going to see in a while. But the idea is that the release is quite a long process. Normally it takes 2 hours plus, and it's quite boring to a live stream of just some person fixing Git errors. So what we have done here to make it a bit funny and more interesting for you is that we have invited a bunch of core developers that are also working on the Python 3.11 release, like the actual code that goes into the release, not the release itself. And they will tell you about what they have done or cool things about Python 3.11. And meanwhile, I'm going to do the actual boring stuff that is not super interesting for you to see in the background, and maybe explaining between the sections what is going on.
Right, but also don't sell yourself short. It's very unusual to get to see an actual release of a programming language live streamed to YouTube. I've never heard of that except for this. So I think it's pretty cool, even though you might find the actual process boring. I think it's fascinating to get like a view into how that actually happens, what goes into that. And I look forward to hearing from you as you go through
it. Probably mystifies also the developers because people think, oh, Python core developers, they don't make mistakes, and then when you see the actual release, you see like, wow, man, that guy sucks. So you will see that we are human as everybody else, and we make a lot of mistakes. Hopefully, not too many. But yeah, awesome.
Excellent. All right. So as Pablo said, we will have guests on here talking about their role in releasing this new update, and also a little bit of other things. And then in between each guest's presentation, we will check back in with Pablo to see how he's doing with the release. So we have a bunch of guests who will be joining us, and let's start welcoming them on the stream. Why don't we start with Brandt Bucher? Are you there, Brandt? Can you hear us?
Brandt, we summon you through the power
up here before us.
There I am.
Oh, there he is.
I am Brandt Bucher. I am part of the core development team, and I'm also part of the faster C Python team at Microsoft. And this is my crazy hat.
Oh, wow. Shark hat. Nice.
There. Yeah.
Python shark.
That works. Cool.
It's all like mirrored. It's tough to center. Okay, there we go.
What are you going to be talking about, Brandt?
I'm going to be talking about my team's work on the new specializing adaptive interpreter that makes your code a lot faster.
Very cool.
Yeah.
I look forward to that. Also with us, we have Mark Shannon. Can we get Mark on the stream?
Hello. I've just realized that the problem with headphones is the hat doesn't sort of work.
Yeah, I also have that problem. So I have one phone up here.
I have to sit very still.
Very fitting.
Oops. Well, I'll try and sort that out later. Anyway, yeah, I'm the tech lead of the Faster C Python team. So I've been making Pablo's life difficult for the last year by changing lots of stuff.
It happened.
It definitely happened.
Yeah, so you're going to be talking about the Speedups then?
Yeah.
So I'm more. So Brandt's going to cover the sort of it changes the interpreter, which is more the sort of direct. That's the sort of thing that does a direct speed up, and I'll be talking more about changes to the memory layout and all sort of stuff. That's more. It has an important effect on performance, but it's less sort of direct and less obvious.
Excellent. This is very interesting. We have a few more guests. Why don't you introduce the rest, Pablo?
Well, the next guest that we have is Irit. Irit, we summoned you. Wow, that was fast.
Hi, I'm Irit Katriel. I'm a Python core dev. I also joined Microsoft Fastest Python team earlier this year. And I will talk about exceptions. There are many changes to exceptions in Python 3.11, not just exception groups. There are a few other things that we did. So I'm going to cover all that. And here is my stupid hat.
Nice.
Is that homemade?
It is not, I'm afraid. I was too busy with exceptions.
No, because it just looks like the dots are very tangible, like three-dimensional.
Oh yeah, they are. They are fine dots.
Very nice.
Right. Awesome. Now, through the power of release management, I summoned the other release manager. Thomas appear here. Wow. Oh wow, two people. Ha! That was a
Uh-oh, sneak peek.
You want me first? You want Łukasz first?
No, I want you first. Thomas.
So I'm
Introduce
Thomas
me.
Wouters. I am going to be the Python 3.12 and 3.13 release manager, which means I get to do Pablo's job next year. I'm also a core developer, sort of required to be a release manager. I'm also on the Python Steering Council, and I'm on the board of directors of the Python Software Foundation, which is the nonprofit behind Python. And also, I have a silly hat, and mine is a Noogler hat, which is the hat that Googlers get when they start at Google. I started at Google in 2006. This is not my Noogler hat. I borrowed one from a friend because I don't remember where mine is, but I thought it was appropriate for the newbie release manager.
It's true.
And, it rotates, of course.
Oh, it spins. Oh, nice.
Good. You must make sure to spin it several times during the stream.
I will do my best.
I realized that when I say I summoned the other release manager, it was an ambiguous request. So that's why we saw Łukasz very briefly. So now I summon Łukasz. Let's say it fully qualified.
Hi
Nice.
there. I'm Łukasz. I'm the older release manager of 3.8 and 3.9. Those are now in security only mode, so they're not pining for the fjords just yet, but you know, like they reach their final stage of life just in time for people to start really adopting them. So we see, like, you know, adoption numbers skyrocket right now. Like, I hope people will move to 3.10 instead. Yeah, today I'm going to be talking a bit about my role as a core developer in residence, but more importantly about all the typing changes coming in Python 3.11.
Very
Nice.
cool. You mentioned adoption numbers. Do you have actual numbers for that? That's super interesting.
Adoption numbers, like we have some, like, just based on the top downloaded packages from PyPI. So we see, you know, how people, you know, are behaving. Like for the top, well, obviously it's not like entirely accurate if somebody uses their own PyPI mirror, or if they have some closed source application, like, you know, somewhere internally that uses an entirely different build system, like Google, Meta, and like all those other giants. However, for, you know, the general community, just PyPI stats are pretty representative on how the community behaves. I forgot the most important thing. That's my stupid hat. I will try to put it on the thing so that I can actually still hear you. Okay.
Nice.
Successful.
Yeah, that
Successful.
looks like it'll work.
Awesome.
Excellent. That's our all-star cast.
Cool,
And
so-
let's, Pablo, can you say a few words about what's happening with 3.11 and what does it involve to release a new language like this? What are you going to start with? What's your first thing?
Right. So let me kind of explain what's going on and how it's going to work. So the Python. So Python. When we release Python, we go through a bunch of intermediate releases. This is actually not the first release we do for 3.11. We have done before a bunch of alpha and beta releases and release candidates. So this is we publish like a snapshot of the development process so people can test it. Hopefully, a lot of people listening, they have been testing their packages with these releases. Hopefully, we have not been breaking them a lot, but we have been doing a bunch of them. And after all of them, now is the final release, which is the one that we're doing right now. So the final release is a bit special in that regard. I will talk what the normal release involves, but the thing that makes it a bit special is how it happens. So normally, and actually the 3.10 release was done this way. Normally, the last release candidate, so that's the second release candidate, that's what we normally release. The reason we don't release directly the release candidate, but we wait a few weeks, is because we want to make sure that maybe there was some big issue or something like that, so we can add just a tiny fix to that and then release it. But 3.11 3.11 has 130 commit after the second release candidate. So the way it works is that now before the stream, because this will be too long and too boring, I manually cherry pick all 130 commits. These mostly include documentation improvements, so you can have the latest documentation available. But there is some critical bug fixes. Some of them caused by unknown people in this stream. We won't say who. And other fixes that someone requested, to have in Python 3.0. So that was quite a boring. There was a lot of merge conflicts. It took me 3 hours to do all of that. But that is done. Right now we have those in a special branch on the Python repo, and that's what we are going to release. So the release process normally, basically, the thing that we do is that we grab a snapshot of the source, in this case, this branch, and we produce. We first we test it, and we make sure that everything looks correct. And then we produce three things. We produce files to install on Linux. That's normally the source, and we sign it. And then we also produce files for Windows and for macOS. So this may sound simple, but those files require a bunch of changes on top of the actual code. So things like changing the release number so it says Python 3.11.0, and a bunch of other small changes that mark the release as final. As part of this process, also we build the documentation, which, as you know, if you have been on the previous release stream, it involves summoning some Lovecraftian gods while building the latest output. We don't know. I actually don't know why we build that, but we do it, and it takes like half an hour or something stupid. You need all the fonts in the world installed, otherwise it doesn't work, as Thomas knows. Yeah, it's quite stupid. But that is also done as part of the release. And also fixing weird stuff, because sometimes these steps fail because something in the source doesn't work, and the release manager needs to fix it. So yeah, that is basically the idea. And after that, we need to kind of update all the web pages and things like that to point links to the correct place. And so this is the simplified version. We do more things. I'm going to quickly share where you can find the process if you are interested on. So hopefully I can just share this. Okay, there you go. So right. Can I just move? There you go. So all of the release process is basically on PEP 101. If you Google PEP 101 Python, you will find this document, and it's a long document that tells you everything that we need to do. So all of these bullet points are steps. We don't execute all of them. Some steps are only for some specific release, but as you can see, there is plenty of stuff here. You can see like a bunch of funny comments here. There is some of them that used to make stop, so like this one. So, to make sure that you stop there for sure, and then you don't make mistakes. But if you're interested on the whole process, you can just read this document. Another thing that we already did for you to know how, because a lot of people find this very interesting last time we discussed it, is the Python buildbots. So the way we know that what we are releasing right now actually works and, is not going to crash on your machine, we have something called the buildbots, which is this other page You can access it if you type buildbot.python.org. So buildbots are a lot of machines that are constantly running Python, and they are executing the test suite with different ways. So sometimes it's executed with some flags, sometimes it's executed in install Python, non-install Python, all operative systems that we care, like Windows, Mac OS, but also FreeBSD and some other weird things, ARM, Intel, etc. And you can see, for instance, that if you go over here, you can see all the different configurations that we have running Python, and you can access one. So for instance, this one is checking 3.11 right now. Takes a while. And you can see here, maybe it's not this one, but well, it's right now it's obviously because you are all looking is getting slower because it's just a tiny machine behind the whole thing, so it's not taking the load. But yeah, now when you are not all looking at the same time, you can probably see the machines producing output, and they will tell you like if a commit is failing or what's going on, and and we have also this page here that now is not going to show because all of you are checking also at the same time. That shows us the release managers when people are not checking what is the current status, and that's basically tell us if some of these builds are failing, and then we need to manually investigate if the failure actually is something that we care or is just a false positive or something like that before the release. I already checked all of that, so we don't need to do it right now. So we can just proceed. I'm going to
Pablo,
share. Yeah,
if I can stop you for a second. You mentioned there's 130 commits that you have to cherry pick.
Yep.
Is that normal, by the way? Did you do that last year?
No, it's not normal. In this case, the reason we have all of this is because, as you will see, 3.11 is packing a lot of changes compared with previous version. Specifically, changes that affect fundamental parts of the interpreter, and this means that unfortunately some of the things get more tricky to test. We are quite happy about the status of the release. We think there is not a lot of bugs, or there is none that we know that are fundamental. But there were more than 310. So this means that.
So what's a more normal number in an everyday release?
One.
Well, how was it last year?
One is a normal number. Yes.
And you mentioned that there was a whole bunch of merge conflicts, right?
Yes. So this is because most of those commits are not actually bug fixes. I think bug fixes there is like 15 or something. Most of those commits are. Let me answer. So most of those commits are actually documentation improvements. This is because a lot of the core developers or contributors did a lot of fixes to the documentation. Actually, quite a lot of hard work. So thank you a lot, everyone that helped here. And unfortunately, some of those commits got merged after release candidate 2. So we need to backport those merges into the branch. The merge conflicts happen because some of those changes are assuming that the rest of the code is there, but I'm not importing the rest of the code. So this means that sometimes when I cherry pick one of these documentation change, it complains because it says, I was supposed to be building on top of this sentence, but this sentence is not there because that sentence is something that someone added after they made an actual code change. And because the code change is not being backported, that is not there. So I needed to manually fix all those cherry picking. It's just,
say you ran into a conflict that was more complex than that. How is it? Does the release manager have the responsibility to resolve those conflicts, or do you have to reach out to the people who were involved in the change?
Normally, if it's just documentation changes, is fine. You just check what is supposed to be because at this stage, the actual canonical status of the documentation is whatever is on the 3.11 branch. So I just make sure that what I produce makes the different documentation be equivalent to the 3.11 branch. So I just need to make sure that I do my work correctly, which apparently I didn't because Guido reminded me that I forgot 1 or 2 commits. So I also sent an email to ask people to help me make sure that I didn't make any mistake. Regarding code changes, if the merge is not clean and it's just messy, normally you reach to the authors because it's not the responsibility of the release manager to fix code that I did right. That will be.
But there's a lot of people involved, right? Can you always? I mean, isn't it a problem to get a hold of them sometimes?
Yes, that's another thing that the release manager needs to do. A bit of
you do a lot of that.
Yeah, using the stick and ping people. I mean, doing it live in the release is probably not the best way because people may be on vacation or on holiday, so they will be enjoying their nightly read a book or whatever. But yes, it's also like you need to make sure that people do these things, and
Right.
otherwise,
So-
like we don't release it with that fix, and that's on them, which is okay.
So have you actually started the release process now, Pablo?
No, I
What
have
are you
not.
doing?
Right, so that's the other
Okay.
thing I want to show. Let me go to the place so you can see what I'm going to execute. Let me just share this so to explain where these things are. So the release process is basically the PEP that I mentioned, but we have here this repo. So I'm showing again. There you go. Thank you. So we have this repo. It's on the Python org. It's called release tools, and here basically you can see all the code that goes into the release. We have this this file that I made on my time as 3.11 and 3.10 release manager that basically tries to do all of those steps as automatic as possible. So what I'm going right now is to start executing this script. I'm going to try to show you how it works, but it's not super interesting, the output. Let me see. So I'm going to share quickly, and then we can start. Okay, so hopefully the share works. Right. So the way this works is that, so I'm going to execute the script. The way it works is that there's a bunch of things that you're not seeing because they are keys and things that are private, but you point it to a particular release, you point it to the place where the source is, and you use the SSH key that you're going to use. And what the script is going to do is that it's going to check a bunch of things. So for instance, it's going to check if I have all the tools that I need installed and they work nicely. And then it's going to ask me like, what GPG key do I want to use to sign? Right now I only have one. And then it's going to start going and trying to check if all billboards are running correctly and if it can access the different servers that you need to access. For instance, checking that indeed I can access this PSF server. And now it's going to start checking for like billboards, something like that, which is going to take a while. So we can stop here.
Okay.
But after that is finished, it's going to start building all these different things that you can see on PEP 101. And probably is going to fail along the path. So I need to manually fix it. But yeah, it's basically, and for instance, right now it's failing. So I need to check what is going on. But like, that is fine. You're not going to need to see how if we fix those problems. But yeah, it's basically going over PEP 101 and doing it manually. So you saw it fails, that it's recorded. Now you can see that I'm not lying.
Yeah. I know someone's going to ask, that prompt, is that Starship? Is that right?
Yes, that prompt is a Starship prompt. Yeah.
Nice.
Cool. So I think we can start with the talks. I think the first one is Brandt, right?
Can I ask you one more question before we
Oh, yeah, absolutely. Sorry.
PEP 101, you mentioned several times. And that document was created a long time ago, right?
Yeah.
Has it been updated since then? Does it change?
Yeah. It has been updated. Maybe not as much as we need. Like the PEP is actually saying what it needs to be done. So there's nothing missing. It's just that it could use some refresh in the sense that there is all these stop things that I think Larry Hastings added that when he was release manager. I don't use it anymore, so maybe we can release. But yes, that PEP is still updated with when we need to do things. Like for instance, right now there is a bunch of changes in the release process that we need to do. We are using SigStore to sign releases. It's like another method to ensure that the artifacts that we release are the ones that we say that we are releasing, and that involves some changes that we made to the release process with some help, and that the PEP, I think it has been updated for that, if I'm not mistaken. But certainly it has been updated for other things. So yes,
so you're also planning to make some updates then, it sounds like.
Yeah. When we find new things or things that didn't work or things that are outdated, we change the PEP. But it should be as close as possible to the truth.
All right, great. Yes, I agree. Let's go to Brandt Bucher, who is going to tell us a little bit about what he's doing for this release.
Yes.
Hey, Brandt.
Let me share everything. Right over there. Awesome. Can you see that okay?
Yep.
There we go. Okay, cool. So today I am going to be talking about the work that a bunch of us have been doing on making CPython 3.11 especially fast. Specifically, I'm going to be talking about the new specializing adaptive interpreter in CPython 3.11. Before I start, a little bit about me. My name is Brandt Bucher. 5 years ago, I started using Python for the first time. In 2018, a year later, I contributed my first code to CPython. A year after that, I joined Python's triage team while I was waiting to be called for jury duty. In 2020, I finally joined the core development team. And exactly a year ago, I joined Microsoft's CPython performance engineering team, or the faster CPython team. I think I even announced that I was joining the team as part of the same release talk last year. And for the last year, I have been working on that team, helping to make CPython faster. And so I'm going to talk about some of that work today. So we are going to be mostly looking at bytecode today. Bytecode is basically, it's like assembly language, but for the Python interpreter. It's okay if you don't know how to read bytecode yet. We'll go over it a little bit. It's not necessary to know to use Python or for Python to make your code faster, but I think it's really interesting, and I think it's the best way of sort of explaining how the new stuff works exactly. So we're going to be looking at the bytecode for my example code here. I have this point class. It has two instance attributes, x and y, which are floating point values. And it has one method, shifted, which basically returns a new instance of my point, but shifted by the given x and y values. So specifically, we're going to be looking at 2 lines from this shifted method, because I think they show specialization off very, very well. If you want to view the bytecode for any function or method, it's really easy to do. You can use the standard library dis module, DIS. And if you call that on any function or method, it will spit out something like this. So this is bytecode. And I'm just going to walk over this real quick and show you how CPython normally executes these 2 lines. As many of us know or might know, CPython is a stack-based virtual machine. So I'll show the stack here on the right-hand side of the screen. So just walking over the bytecode verbally, we start by loading 2 fast local variables, dy and self, and pushing those onto the stack. Then the load adder instruction loads the y attribute from the top of the stack, and we add them together using binary op. Finally, we pop the result off the stack and store it in the fast local variable y. Then, executing the second line, we load the global name type from the built-ins. Then we load another fast local variable, self. And then the pre-call and call instructions work together to call type on self. And then, again, we pop the result and store it in class. So that's kind of an introduction into what bytecode normally looks like. But what's really cool about CPython 3.11 is that we've actually changed the bytecode. So how did we change it? Well, we do something called quickening. And quickening is really cool. Quickening happens at runtime as your code is running. And it basically involves the interpreter walking over each of the instructions in the bytecode stream and replacing them with versions that could be faster later. Again, this all happens at runtime. So if you want to view quickened bytecode, you can pass adaptive equals true to the dis function starting in Python 3.11. Now, if you don't actually run your code, or if the function that you're calling dis on has only been run not at all, or maybe a handful of times, you won't see anything different. And that's because we don't want to waste time quickening code that is hardly ever run. But once your code gets hot, or once it's been run more than a handful of times, quickening begins. And I'm going to kind of go over the different steps that involves. So the first thing that we do when quickening code is we insert what are called super instructions. And super instructions are pretty straightforward. It's basically taking 2 related operations. So for example, the 2 fast local loads that start this bytecode stream, and combining them into a single super instruction. In this case, load fast, load fast. And this will basically load both of those fast local variables simultaneously as part of the same instruction, rather than having to dispatch twice and run 2 bytecode instructions. So super instructions are pretty straightforward. But there are very simple, and it's kind of easy to see how they make your code faster. The much more interesting sort of quickening that we do, in my opinion, is inserting what are called adaptive instructions. And this is what I'm going to spend the rest of the time talking about today. So adaptive instructions are inserted at the sites of several of the most common operations that we might want to optimize later. You can see 5 examples here. Things like attribute loads, global loads, binary operations, and calls are good examples of operations that we turn into adaptive instructions. And basically what adaptive instructions do is they will do the same work as the non-adaptive version of the instruction, but they'll remember some of what that work involved, and they'll cache that information for later. After they've actually done the work, they then turn themselves into a specialized instruction. And a specialized instruction is one that can reuse that information that has already been computed later, as long as certain conditions hold. So I know that was a lot, so I think it's best to show some examples of specialization in action. So let's consider the load adder adaptive instruction. Attribute loads in Python are fully generic. Attributes can come from a lot of different places. They can be loading attributes off of modules. You could be loading methods or class variables off of classes. You could be loading slots off of an instance. You could even be calling into dunder get adder or dunder get attribute. In this case, we are just pulling attributes out of an instance dictionary. So after load adder adaptive runs for the very first time, it will replace itself with load adder instance value, which is specialized for instance attribute access out of an instance dictionary. And load adder instance value actually starts with a fast path for doing this sort of more specific work. So rather than a general attribute load, what load adder instance value will do is ask a few questions. First, it checks if the class is the same as the last time. So the last time this specific instruction was hit, was it with the same class? If so, check if the object's instance dictionary keys are the same as last time. If so, then we can actually skip the dictionary lookup entirely. And this is really, really powerful. So because the keys of the dictionary are the same as last time, even if we have 2 different instances with 2 different instance dictionaries, we know where the actual attribute lies in the dictionary's internal values array. So we can skip looking into the hash table or hashing the key or handling collisions and just reach directly into the values array at the same offset and return that result instead. So this is a good example of something that can be specialized very, very effectively, especially if you're getting instances of the same point class coming through. One thing to note is that if either of these checks fail, we don't crash or error or anything. It's really important that we need to be fully transparent and still do things correctly, even if your code is very dynamic and things change with time. So if either of these checks fail, we actually just fall back on the old load adder slow path. So we still do the right thing, it just won't hit this fast path and be as effective as it could be. So that's load adder instance value. Let's look at another one. Binary op adaptive is pretty straightforward. Since dy and self.y are both floating point values in this specific case, binary op adaptive will replace itself with an operation specialized for adding floats, binary op add float. And this is similar. It will check if the left-hand side is exactly a floating point type. It will check if the right-hand side is a floating point type. And if so, we don't need to go through all the overhead of Python's object-oriented dynamic dispatch for operator overloading. Instead, we can skip all of that and just add the raw floating point values together in C and return that result. So we remove a lot of overhead from what should really be a very simple numeric operation. And again, if either of those are not floats, for example, if you throw an integer into this thing, then we'll still do the right thing. It just won't hit this fast path. Load global adaptive is another good example of a common operation that can be specialized very, very well. In this case, since we're loading the type built in, we are always going to be getting it from the built-ins dictionary. So load global adaptive will replace itself with load global built-in. And I think it's important to understand what happens when you're actually loading a name like this from outside of the local variable namespace. Every time that we look up type in this function, there are two dictionary lookups that have to happen. First, we check the globals dictionary for that module to see if type has been shadowed in the globals. That will fail, and then we have to look up type in the built-ins, which will succeed. So even in the best case for normal Python code, every time you look up type, we need to actually perform two dictionary lookups, one failing one and one successful one. However, we can specialize this in a way similar to load adder. So what we can do is we can check if the global dictionary keys are the same as last time. If so, we know that type doesn't exist in the globals. It hasn't been shadowed. And so we can skip that lookup entirely. Then we can check if the built-in dictionary keys are the same as last time. And just like the instance attribute access, if the dictionary keys are the same for the built-in, we actually don't have to perform that lookup anymore. We can just reach directly into the internal values array and grab the value out without performing any lookups. And then we can just return the result with, of course, slow paths if either of these uncommon conditions arise. Finally, the pre-call and call adaptive, when we're calling type on self, both combine and specialize into an instruction specialized for calling the type built-in. Since this is a really common function that people call, basically what we've done is we've created a specialized instruction for calling type. Rather than actually performing a call, which is, relatively expensive, there is overhead associated with that. We can instead just check if the object that we're calling is still the type built-in. If so, meaning it hasn't been monkey patched in the built-ins or it hasn't been shadowed in the global namespace, what we can actually do is we can just get the arguments class without performing a call at all. This is super fast in C. And this is about as low overhead as you can get for looking up the class of a type. And then finally return the result, of course, with a fallback path if we do need to de-optimize. And so by looking at this, you can see that after each instruction has specialized, basically after we've quickened and then all the adaptive instructions have run, we now have bytecode that is custom tailored to the exact types and values and context that these two lines are being run in. And one thing that's important is that this continues to happen repeatedly. For example, let's say that I start using integers for my point classes at one point in a program. So rather than having floating point values, my X and Y attributes are now integers. This binary op add float will repeatedly de-optimize itself. It will keep going to that slow path that goes back to the generic operator dispatch. Well, what happens is after a certain number of those failures, the interpreter will change this back into binary op adaptive. And then the next time it runs, it will turn into the new binary op add int, which is just like binary op add float, but specialized for adding integers instead. And so this is truly what we mean by a specializing adaptive interpreter. The specializations actually adapt with your code over time. As your program runs and you hit new code paths or data changes or the greater context changes, the code changes along with it to make sure that you're always getting that peak performance that the interpreter can offer. And because this happens at runtime, it's able to adapt to this in real time, which is really, really neat. So you might be asking yourself, it's clear that we're caching a lot of information here. For example, we're caching lots of information about classes and dictionary keys and offsets into dictionaries. Where's all that information stored? The answer is we use inline caches, and those caches are directly in the bytecode itself. So we actually hide these caches by default when you're viewing with this. But if you pass show caches equals true to any dis utility, you'll actually see that there are quite a few inline cache entries that accompany these adaptive and specialized instructions. So these are where we store information about dictionary keys, offset indexes, and de-optimization counters, amongst other things. So it's not really all that useful to see these caches most of the time, which is why we hide them by default. And in fact, you shouldn't really have to care about adaptive instructions at all. The whole point of our changes are that everything is totally transparent. We always do the right thing, even in the face of changing code. You shouldn't have to really know or care exactly how your code is specializing, because the only thing that you should notice is that your code got faster. And in fact, in the case of point.shifted, that specific function, just based on some timings that I did about an hour ago, that specific function got about twice as fast as Python 3.10. Now, that's definitely on the high end of the sort of improvements that you can see. I obviously chose that example because it's very well specializable. But I think it does kind of highlight how just making these little changes and providing those fast paths that change over time can really, really lead to real improvements. But you shouldn't really have to worry about bytecode at all, right? But what if you're like me and you run your code and you see, oh, wow, Python made my shifted method almost twice as fast. That's really impressive. How is it doing that? What got faster? Well, you might start looking at the full bytecode disassembly for your shifted method, but it's kind of overwhelming. Even as someone who stares at bytecode disassemblies all day, for me, even it's hard to see where the interpreter is successfully specializing things. And where it's not successfully specializing things, where the adaptive opcodes are unable to specialize. It would be really nice if instead we were able to map these bytecode instructions back to source code. For example, to see each individual line as it's built up of the bytecode instructions and see what is being specialized and what isn't. Well, if you're like me and you want to see this sort of information, you're in luck, because I created a tool to help visualize this. What you're looking at right now is a screenshot from a tool I wrote called Specialist. Specialist is really, really neat. It will basically run your code. So rather than running with Python 3.11, you run your code with Specialist, as you can see here. And after your code is done running, Specialist will open a web browser and display this HTML, which is basically a colored copy of your source code. And from that, you can see where things are specializing successfully or failing to specialize. So in the case of our shifted function that got twice as fast, we can see that the first 3 lines are specializing extremely well. Those are the ones that I showed you in the example. However, the final line, return class, is not specializing well, which is why it's red here. The reason that it's not specializing well is because specializing class construction is actually pretty tricky. It's much harder to specialize than normal function calls, like we have for type self, for instance. So this is something that we're actively working on for 3.12, but something that doesn't specialize in 3.11. So again, all the specialization happens at runtime. So Specialist isn't a static analysis tool that runs like MyPy or PyLint over your source files. You actually need to run something. So in this example file, I actually run something. I call the shifted method about 100 times in order to see how the code specializes and adapts like that. So Specialist is available on pip. As soon as Pablo finishes his release and you install 3.11, your first pip install can be pip install Specialist. You can run that over your code and see exactly where we made it faster. Specialist is also available on GitHub, so you can check it out. It's Brandt Bucher, that's me, /specialist. And that's it. If you're curious to learn more about the specializing adaptive interpreter, you can check out PEP 659, which contains a kind of a higher level overview and more examples of the sort of stuff that I covered here today. And that's it. Thank you very much for watching this. I'm at Brandt Bucher on GitHub and Python Discord. You can ping me anytime, I don't care. And I can also be emailed at brandt@python.org. Thank you.
That's great, Brandt. I think we may have time for a couple of questions from the audience. If anyone has anything directly pertaining to the talk.
Cool.
We'll see if we can bring some of those on to the screen. One question we're getting here. Did bytecode code caching exist before 3.11?
Yeah, so since 3.8, we have actually had a different caching mechanism for, I believe, attribute loads and global name loads. Because as I explained in the talk, those are kind of really good opportunities for this sort of caching. So the mechanism for those changed. They didn't use the same quickening mechanism that all the other instructions use. So we did unify that. But yes, attribute loads and global loads have had that same sort of caching since 3.8. Yeah.
All right, cool.
But it wasn't exactly in the bytecodes. It wasn't, looking at the instruction now, or the question now, it wasn't those cache entries in the bytecode itself. Those were a separately allocated memory array.
All right. Does the quickened code get written back to the PyC file so that subsequent runs also profit?
No. Quickening is something that happens pretty quickly if your code is getting hot. It's actually pretty tricky to write back to PYCs because we store things like pointers and type and dictionary versions in there, and those are only valid within the context of the running process. So it would add considerable overhead and difficulty to be able to serialize that information back to disk, especially since you need to repeatedly keep writing it as things adapt over time. So generally, it's not really worth it because this sort of stuff specializes very quickly anyways.
Then we get a question, is there any way this improves exec and eval speed? How about nested functions?
In general, exec and eval probably won't see this unless, for example, you're execing or evaling loops that get really, really hot. So if you're execing or evaling single statements or single blocks, honestly, the code won't run enough to be identified as code that can be quickened.
All right. Yeah. And the nested functions?
Oh, nested functions. Yeah, those get specialized the same way as any Python function, with the caveat that every time you recreate a nested function, at least in 3.11, we're hoping to improve this in the future, but every time you create a new nested function, it's going to share the same specialized code as the past times that you created that same function. So they'll share the same specialization and de-optimization machinery.
Perfect. All right, thank you, Brandt. I think we're going to check in then with Pablo to see how he's doing with the release. Hey, Pablo.
Hey, what's up? So right now, let's see if I can share. Yeah, there you go. So right now, what we're doing, we have most. I think we can move the share to the page. No, it's backstage. Well, anyway, I can describe what. There you go. So right now, we basically created all the documentation nonsense running all the LaTeX craziness. They literally just filled my buffer, so I cannot even show it to you. So what we're doing right now is doing a last test of the sources. So I have produced a Tor file with all the sources, with the changes and everything there, and I have installed that on the machine, and now it's running the Python test suite again in a single process. The reason it's running on a single process is because some of the problems only happen when you run it on a single process. That is what is going on. And it also runs it by itself, and then it runs it with a bunch of specific compiler options to check for errors like sanitizers. And so we check address sanitizer and thread sanitizer, and they also will check with Valgrind. So right now I think it's just doing the last one with the sanitizers. That's why it's a bit slow. But yeah, now we are waiting for all the test suite to pass. And once it passes, because I'm quite confident it will, this is just to check if anything went wrong. Sometimes it happens that, at this stage we discover some weird stuff, unfortunately, but it's getting rare and rare. So once this passes, we can just proceed to continue and upload the artifacts and start building the Windows and macOS versions. So yeah, that's what's going on.
Okay. How long until the next big thing? In the next step, how long until we get there, do you think?
Sorry, I was just checking something. So until the next step, probably 20 minutes at least. Testing is quite long. to a bunch of talks, I'm quite sure.
Yeah, perfect. Well, then we have time to hear from Mark Shannon about the other types of speedups we're seeing in Python 3.11 other than the specializing adaptive interpreter. Hey, Mark.
Mark.
You're muted.
I'm going to do a little quick presentation, so should be finished well in time for the next step. Or I don't know, we can maybe move on to Irit after that, but let me see how this work.
You won't mind having a couple of questions after the talk as well, right? So maybe we'll pad with that.
Try to see what I'm sharing here. Okay. Let's press a lot of buttons. This. See this now. Can you now see that? Yes.
Yes.
Okay. So this is just a little short thing on an improvement we made. So I don't know how much people know about Python frames, but basically, if you run basically any language, any code in any language, apart from like archaic versions of Fortran, you need a stack. So if we've got this little function, define foo, it takes an argument x, we need someone to put the x, and of course foo might be called by something that foo calls. So we need an version of x for each instantiation. So consequently, it needs to go on a stack. Up till Python, well, actually, this is all a general thing. So we have frame objects in Python, which you'll see in a traceback, or if you doing profiling or various other things like that. And it looks something like this. There's a header because it's a Python object, and then a pointer to the previous one, and then just the non-locals, globals built in, some debug and trace info, pointer to the function that's actually being called. It's local variables and the evaluation stack for temporary variables. Okay, so as I said, we need a stack, and these stacks are made up of like a linked list of frames. So up until Python 3.10, these are all allocated on the heap. So every time we make a function call, we need to allocate a new piece of memory. There was some caching, but it wasn't 100%, and it's still a lot of bits of memory sort of all over the bits of memory can just be all over the place. So this is not very efficient. So what we've done in 3.10 is we're basically allocating big chunks of memory for the frames, and almost all frames are allocated inside these chunks. So instead of having to allocate a new piece of memory, all we do is just move a little internal pointer and just use the new frame. So that's considerably more efficient. So if we make a call, we need a new frame, but rather than having to allocate a new piece of memory, we can just stick the new one in there. So it looks something like this. Now, this is what C, Java, and many other languages do. But the problem, of course, is this doesn't really handle generators and is problematic with tracebacks and introspection and so on, because previously we had these frames were full Python objects, and now these are sort of limited little things. So this is how we handle the other sort of bits and pieces. So if there's a generator, the generator remains in the heap, and we just sort of link in the generator. So if we're sort of iterating over generator, which itself is called from other things, that the generator is just on the heap. So we still get most of the efficiency, but we need to allocate the generator on the heap. Now, sometimes we actually need a frame object, particularly tracebacks if an exception is raised, or for introspection. So suppose we have this stack frame, these 3 frames on the stack, and we need to create a frame object. So this is the currently sort of active frame. This one I've marked in green here. And all we do is simply create a new frame object on the heap and just point to it. If that frame object goes away before we need to return, that's fine. We just carry on as we would before. But if the frame object outlives the frame, we basically just copy the data from where the frame was here into the frame object, decouple it from our stack, and carry on. And that's basically it. Now, this is it's not too super clever or super fancy, but it's one of those things that just is part of the sort of many changes we've made to 3.11. That it adds, a few percent here. So it's one of these many little changes. I just thought I'd present it to sort of show that it's not just the big stuff like the specializing interpreter. There's sort of lots of little things, improving data layout and little efficiencies that we've made in 3.11 that hopefully should make the whole thing 3.11 just feel more responsive and quicker than 3.10 was. Okay, well that's me. I have a longer one later if depending on the timing. So
Excellent. Thank you, Mark. A quick question from me. This making Python faster project, that's your brainchild, isn't it? That's a long, ongoing project.
well, it's hardly an original idea that we could make Python faster. I mean, it's
Sure, but the implementation details, I think I've seen in a repository with your name on it, yeah?
Yeah, so I mean, I did my PhD on dynamic virtual machines for dynamic languages, that over 12 years ago or something. So obviously I've been interested in this for a long time. But yeah, I was sort of pushing for this just pre-pandemic, obviously, and everything got put on hold with the pandemic. And then Guido, starting at Microsoft, managed to find some funding. So Microsoft are now paying for this sort of stuff, and that's the sort of key thing that's pushing this forward. I think it's just that there's money available now, that Python has become important enough and popular enough that companies are willing to fund this stuff. I think I mean, I've wanted to do this for a long time, but it's the money that makes it possible.
It sounds like you're having fun.
Yeah. Oh yeah.
So to speak more to the high level, like what's like really roughly high level the steps in the subsequent releases that you guys are going to be looking at?
Okay, well, there's a bit more of the same. So like I said, we'll do a talk later about like how we've reduced the sort of object size and how that sort of started back in 3.3 and is continuing forwards. So it's an ongoing sort of progress of these little things, but they're the big, feature that the big headline feature that everyone's expecting is a just-in-time compiler. That's the thing that makes all the JavaScript engines fast, Java fast. So that's the sort of the big thing, but a lot of the reason we're not pushing on that now is because there's loads of evidence that if you try and do that without all of the other bits in place, it's just a lot of effort and you don't get much results out of it. So that will be sort of 3.13, 3.14. So for 3.12, I suspect it's more of the same and probably memory management stuff.
Right.
So lower garbage collector overhead, fewer garbage collection cycles. Again, better memory layout and just things like that. So.
Precisely. Okay, thank you so much. Do we have any questions from the audience for Mark? We probably have time for a few. Michelle Simone asks, can you show C code of a frame?
I can probably hunt around on
It's
GitHub.
an interesting question. That means that if you can show it in the screen or you can show it in Python.
Yeah, I think that's probably asking to show it on the stream.
Okay, well, let's see if we can...
I don't even know if the question makes sense.
Well, we can always go to... Let's find... There we go.
Maybe they are asking you to start GDB and so...
well, no. I mean, we can just look at the header files, I guess. It's probably not very exciting, though.
Right.
So, internal PyCore frame. This is going to be confusing for anyone who doesn't know C, and probably confusing for people who do as well. So this is the current frame in 3.12 at the latest. So
we can't see your screen right now. Are you sharing that?
Oh, okay. Yeah, sorry. Right, that will probably help, wouldn't it?
It might.
many buttons to be pressed. Okay, so this is the frame object. So the struct frame here is the frame object. At the end here is the frame data, which is only valid if the frame object outlives the execution frame. So the data in there gets copied in. That was the bit I'd colored in green. Is the back, which is the sort of linked list pointer through frame objects, which is sort of, again, only is valid if it outlives the actual frame. I'm just running where the header for the actual frame itself is. Oh, here we go. Again, there's the previous pointer. So that points to the previous frame. And then here's our pointer to our frame object, which is, again, is null unless someone creates the actual frame. So yeah, it's all fairly sort of low level and convoluted, and it is documented as well if anyone's interested. And I'm trying to remember where. So I think that's in objects. Let's have a look under F for frame. And there's a markdown file which sort of explains how this sort of works, although I'm not sure how understandable this is unless you already know how it works. It's probably a reminder for the expert rather than an explanation for the beginner. But it's there if people want to have a look.
Perfect. Let's see if we can provide a link for that to the chat as well. Okay, so we got one more question. Afla says, since there are mentions that over the next few years Python is headed to like a 5x speed boost, which factor do you think will contribute most to this gain?
Okay, well, I'm going to slightly change the question here and say that 5x speed boost is a 80% reduction in the time taken, because programs don't go fast, because speed is, distance divided by time, whereas programs just take time, they don't go anywhere. So the question is, how do we remove that 80% overhead? And the point is, there's no magic way of doing anything, because you can't reduce the overhead of doing, you can't reduce the time taken to do any particular thing to less than 0. So if you've got, it doesn't matter how much you make half of a program fast, it isn't going more than twice as fast. So unfortunately, so it just means there are many different things that need to be done. The most important thing is specialization, which is why we've sort of focused on that first, because just-in-time for dynamic languages, just-in-time compilation without specialization is pretty much useless. But with good specialization, it's a very powerful thing. So specialization is the sort of the key thing, but there are many aspects and you have to do them all, otherwise you don't get the big speed up.
Mm-hmm. It's more about the death by 1,000 cuts rather than some magic bullet solution.
Yeah.
I see. Excellent. Very interesting, Mark. We've got another one from Jacek. Are there already known code snippets that will run slower after the changes because of the copying frames, for example?
Yeah, I mean, it's quite easy to, if you know how something works, to design code that will sort of defeat the optimizations. I mean, the best thing is to design code so that immediately it specializes, it changes the type until that we try and adapt, and then does the same trick again, so that you're constantly working on slower. Yeah, so we're constantly mis-specialized. I mean, if you design your code to be slow, it can be slow. But there shouldn't be any sort of general code that's slow. And that's kind of the point of the adaptive thing, is that it generally will work reasonably well, because if code sort of changes as it runs, we can adapt reasonably quickly. And yeah, we just generally aim to be no worse in pretty much all cases.
Yeah. All right. Perfect. I think that's good, and we should check back on Pablo. Thank you so much, Mark. Maybe we'll check in with you a little later in the stream.
Hey, so we have
Pablo.
some updates. We have finished checking the things on crash. That's nice. So at this stage, I have uploaded the documentation to the documentation server. That still is not is not live because that is something that happens at the end. Probably actually it will take a while until tomorrow. It's not going to be there. But the other thing I have done is that I have uploaded the Tor files to the server, and then I have pushed the tag to my fork. And then the other platform release managers, that is Ned and Steve, are starting to build the macOS and Windows respectively. Steve has given me permission to show his super fancy release process. So Steve has been able to actually automate the whole thing. So hopefully we can move the share to the stream. And he has this. Oh, can we move the share here in the screen? Is that possible?
Yeah.
Otherwise,
let's get the share on the.
There you go. So Steve has this Azure pipelines stuff that so it's like all the things happening. So these things, if I'm not mistaken, builds the Windows release artifacts for. So this is the installer, the thing that you unload, and then it says, "Oh, install Python in Windows." And this builds it for 32 bits, 64 bits, and also ARM64, I think now, which is quite cool. And then I think it tests it as well. Maybe it doesn't, but it does all this. Yeah, it tested here. You can see it here. And then after this script is finished, all the files are uploaded to the server, so I can continue from there. So right now, what we are doing is we are waiting for Ned and Steve to finish this build. And once that is there, I can continue. Meanwhile, I'm just checking a bunch of weird things that I saw. Nothing code-wise. It's just administrative tools that are not working today. So I'm just fixing those small problems. But right now, the release is kind of waiting for these things to happen.
All right. Okay. Good. Let's hear from Irit Katriel on changes to exceptions in this release. While you do that, Pablo, and then we'll check in with you later again. Hey, Irit. You might be muted.
Yeah, hi. Sorry, I just lost the window. So how do I show my screen? There we go.
There's a present button.
Yes, show screen. I don't know what I'm showing now, but this one. There we go. Sorry about that. We good?
Yes, it is on the screen now.
Okay, good. So, right. Will this work? Okay.
There's a
Sorry.
present button in the top right, is there not? I think top right.
Here, right? Yeah,
Oh,
there
that
we go.
works. Yeah, perfect.
Okay, sorry about that. Right, so as I said, I'm Irit Katriel. I'm a core developer. If you look for me anywhere, GitHub or Twitter or whatever, that would be my username, my full name. I'm here to talk about what we did to exceptions in 3.11. We did quite a lot to exceptions. I think the last big change to exceptions was in 3.0 when we added chaining. But now we have quite a few things that happen. So there are two PEPs that kind of describe new features. Exception groups and except stars is one big PEP, and then there's notes on exceptions. And then there are improvements that are kind of internal, but I'll talk about them a little bit. So zero cost exceptions, Mark implemented that. And then the exe info, if you know that this is, you need to be a real geek to care about this last bit, but you're here, so I'll talk about it. And so all of this is my work, things that I worked on except for zero cost exceptions, which is Mark's work. So let's start with exception groups and except star. This is a major new feature that we added. It was a PEP that about 2 years ago we started kind of implementing the prototype. In February we had the PEP. It took some time until September until it was reviewed by the community and by the steering council, and then it was accepted, and then we merged the code in December, and finally today it is being released. So, and this is the idea is we want to be able to raise more than one exception. So we did something that involved several computations, and we got several errors, and they are unrelated to each other. They're not going to be chained. Neither is the cause or the context of the other. They are just separate exceptions, and we want to raise them together. So this is an example of what the socket module does now when it tries to create a connection. It kind of iterates over the configurations that the current host supports, and it tries to connect. And if it finds a configuration that the other machine supports, it has a connection. If all the attempts fail, then currently it will just raise the last exception, and you don't know what happened other than why the last attempt failed. And in Python 3.11, you get a group of all the exceptions. So you know how many attempts were made, you know why each of them failed. But the use case that actually motivated exception groups was a replacement for async.io gather. So in async.io, there's a function that you can give it a list of awaitables, and it will wait for them to finish and return the results in a list. And then if any of those tasks raised an exception, then you can choose whether you want to just get one exception and not know about the rest, or you can get them returned in the list. So you can kind of iterate over the list and inspect them and figure out what happened, but you can't handle exceptions with try except. So this was, and there are other problems with gather. The fact that you can't, there's no automatic canceling of all the, if one task raises an exception, you maybe want all the others to be canceled or some kind of policy, but and gather doesn't do that. It just lets them keep running, and you have no access to the results. So they just kind of keep running and consuming resources and doing nothing useful. So for quite a while, the plan was to implement something like trio nurseries called task groups, which would replace async.io gather and give a better abstraction for kind of groups of tasks. And it looks something like this. This is from the tutorial. You create a task group. It's a context manager. Any task that you create in the context on this task group will be awaited at the end and automatically. And if any of them gets canceled, then all the tasks in the group get canceled. And what was holding this up for quite a long time was exception handling. There was no good way to handle exceptions from a task group, and the acrobatics that Trio was forced to do were just not seen as a solution that can go into the standard Python library. So this is why exception groups were implemented. And I'm not an expert on async.io, so I'd appreciate if you didn't ask me about edge cases of this thing. If we go back to exception groups, what we added were two things. So there's the exception group. It's the exception that wraps a list of other exceptions, and also a way to handle groups. So the exception group is nothing new. It's the same as trio multi-error or similar exception wrappers that you have in all sorts of places where they needed to implement something like an exception group. So that is not new, but except star is new. This is not something that you've probably ever seen before. So except star generalizes except for groups. So if you accept star OS error, then you're handling all the OS errors from the group in that clause. That's the idea. And if we look at exception group is a group, it contains a list of exceptions, and those exceptions could be groups as well, because it's just an exception. So you end up with a tree, right? Here we have two nested groups, and the leaves are just kind of non-group exceptions of whatever types, and the traceback kind of shows this tree. It shows how exceptions are nested and how they're grouped together. So you can see kind of what happened in your program, which exceptions got grouped and raised together. And so the kind of the most important thing you want to know about exception groups is that you can split a group on some predicate. You can split on a type. You can give it other types of predicates. It's quite flexible, but what really matters is you can split on a type. So here we split on green triangles, so we get the matching part of the exception group and the rest, kind of. And everything kind of maintains the structure of the group, of the original group. So if we kind of walk through except star, how it works, so we raise this exception group, we have except star green triangle, then that except star will split on green triangle and bind this matching part to E, execute the clause, and now all the green triangles have been handled. So they are consumed, they're not kind of considered for matching anymore, and the next except star sees the remaining exception group with just the other leaf exceptions. It extracts from it what it wants to handle, and then everything else gets re-raised. So that's how except star works, roughly. And then the PEP is very long, and when we first kind of published the draft, the Twitter reaction was something like, "Oh, the PEP is long, therefore it's complicated, therefore it's no good." The PEP is long because there are all kinds of edge cases, and if you look at like what happens when you raise exceptions from within except star clauses, then there are all kinds of different cases that you need to consider, and but you don't need to care about it when you're writing programs. So that's the point. So the PEP is long because you need to kind of specify how it works in each case, but it's not something that you need to keep in your head when you're writing code. You kind of it should kind of make sense whatever happens. So now that complicated example, I walked through it in a talk that I gave in PyCon UK last month. So it's on YouTube. So if you want to kind of walk through all that complicated example, and I also talked there about kind of some of the design choices we made and some of the kind of discussions we had, about alternative design choices that we could have made. So if you're interested, then my talk is there. There's also a talk that Łukasz gave earlier this year about particularly about how exception groups will help async IO task groups. And so if you're interested in that aspect, I would recommend Łukasz talk. And then there's the documentation, obviously, there's the PEP, there's all the stuff we provided from Python, but also Real Python wrote a really good tutorial about the subject, and way back when we just published the PEP, there was a good article kind of talking about the discussion as of that time by Jake Edge. So you could look that up if you want a bit more of the history of this feature. Now, the second PEP is 678. That's enriching exceptions with notes. So this is kind of an offshoot of exception groups, but it's a very simple PEP. It's unlike 654. This is a very simple PEP. The idea here is when you raise an exception, you choose the type of the exception. You give it an exception message. You can give it more parameters depending on its type. but sometimes when you catch an exception, you have some context information that you want to enrich it with. Something like, what was your program doing when this exception occurred? What was the application trying to do? That's typically, I think, the kind of information you will want to add. And there isn't a good way to add it to exceptions as they are, because the exception message is just the result of the Dundas-Stra method of the exception. So you can't change that in a generic way on exceptions. So this PEP says you can add a note to an exception. You can add multiple notes. It will be kind of a list of strings, and the traceback, the default traceback printing code of Python will print them after the str of the exception. That's all it is. So it's a very simple idea, but where it came from, this PEP was written by Zach Hadford-Dodds of Hypothesis fame, and he was so the history is it came from this PR discussion. So this is the PR where I was implementing exception groups after the PEP was approved, and Zach was he was involved, kind of helping. He was reviewing this PR and he was trying the code, and he was kind of really helping the development in that way. And it's very useful to get someone who says, I need this feature, to just take the code and try it out. It's just it feels completely different to develop when you have that kind of feedback. And he was subclassing exception group, and we were kind of asking, why are you subclassing exception group? We allowed in the PEP. Initially, we kind of thought, no, nobody should subclass groups, and then we were convinced in the discussions that yes, people might want to subclass. So we made it possible to subclass exception groups. We added some hooks, but we didn't think it's something that people would want to do very frequently. So we're kind of asking, why are you doing this? And he was explaining that in Hypothesis, what he does is he writes tests like this, and then the library will execute the test many times with different inputs, and it needs to report, on this input I got this error, and on that input I got that error. So he needed to attach the context. Which test was I running? Which input was I feeding into the system now when I got this error? And he couldn't do it with exception groups, so he was writing some subclass to do that. And we thought, well, this is a pretty generic problem. He's not going to be the last person who has this problem, so what can we do about it? And then if you want to see where exception notes were born, just go to this PR and look at the discussion, because that's where we kind of ended up with this idea that actually we need to be able to enrich an exception with context information. And this is not actually an exception group feature, it's an exception feature. The leaf exceptions need to be enriched. So, and this is what Zach put in the PEP. Initially, I thought this is such a small feature, I just implemented and pushed it. But then there was a kind of, wait a minute, what are you doing? You're changing a built-in, and you can't do that without a PEP. So that's when I went back to Zach and said, hey, can you write a PEP? And then he wrote the PEP. So this is just a bit of behind-the-scenes history of what happened. And this is an example that Zach has from the PEP, how he does exactly what you saw before, but with exception groups. So that is exception notes. And I will add that writing the PEP was not by any means a useless exercise, because we had some good discussions and feedback from other potential users, and we did make some changes. In particular, the notes now, it's a list of strings, and the reason for that is because we wanted to make it possible to register translations for individual notes. And if we kind of concatenate notes as we go along, then the translations don't work anymore because the strings are kind of jumbled. So there was some very useful feedback, and there were changes during that PEP discussion. So I'm glad we did it, and yeah, it's a good process. Zero cost exception handling. That's the third item I wanted to talk about. This is what Mark implemented for Python 3.11. So the idea here is that try except should not cost you anything if an exception was not raised. So if you raise an exception, you're in a slow path, that should take time, but in the happy path, when no exception is raised, the try except shouldn't cost anything. And in Python 3.10, that wasn't true. There was try was this setup finally opcode, and then at the end of the try block, you had to pop. Setup finally says from now on, if there's an exception, you need to jump to line 12, the exception handler, and pop block says pop that, and it's a stack of exception handlers. So whatever was before, that's now the exception handler. So in 3.11, the zero cost exception handling, the idea is that you just write your code, and in addition to aside from the code, there's an exception table that says if there's an exception between lines 4 and 6, then you jump to line 12. So at runtime, you don't do anything with that information unless an exception is raised, and then you go to the table and look up where do I need to jump. That's a bit slow, but we raised an exception, so we don't care, we're in the slow path anyway. So that's the idea. There is this no up here. It's still there. No up is an opcode that doesn't do anything. And the reason it's there is because we need the trace to say that something happened on line 3. We need some kind of opcode that executes and is associated with line 3, because otherwise your code coverage stats won't show that line 3 executed. So that's what it is. It's for line number tracing. But no up is a very cheap opcode, so it's still okay to say it's zero cost. There is one other way in which this is not quite zero cost. I changed my example. I added some code after the except block. So now in the happy path, we don't return at the end of the try block. We have to execute this x equals 3 as well. So now in 3.11, we have this jump over, we lay out the try block, then a jump to the code that's after the except block, and then we have the exception handler. And you can see that if there's an exception between lines 4 and 6, we jump to 10 to the exception handler. And if there isn't, then we have to jump over the exception handler and then execute the rest of the code. And in Python 3.12, the layout will change. So I kind of noticed this and just thought, hey, Mark, this isn't zero. The truth is this doesn't make a noticeable difference on benchmarks, unfortunately, but we do have this change in 3.12. So now it really is very close to zero cost. You don't even have to jump over the exception handler. So it will be zero will be even more zero in 3.12, but it's pretty close to zero now. Now, one last item. Now, this is like, yeah, this is kind of internal, not entirely, but so exe info. If you know this sys exe info function, if you're in an except handler, you can call it and get, this is the exception that is currently being handled. And it returns a tuple of 3 items. So the first one is the type of the exception. The second is the exception itself, the object. And the third is the traceback. Now, the first and the third are redundant because you can get them from the exception. The traceback is attached to the exception, and the type of the exception is just the type. So why is it like that? So it's historical reasons and kind of evolution of the way things are implemented. So inside the interpreter, the raised exception, not the handled exception that was already caught by an except, but an exception that was raised but not caught yet, that may be just a type. It's possible to just raise an exception, just the type, and not create an instance. And there are situations where the instance will never be created if the exception is handled before it ever reaches Python, back to Python. So deep inside the interpreter, it does make sense to have this 3-item representation. And the dunder traceback field is new in Python 3. In Python 2, it didn't exist, so that redundancy wasn't there. But now we do have that redundancy. And the thing is that where there is redundancies, there are usually bugs, and this is no exception. So if you look at this code, in the function f, we raise an exception, we catch it, we set it to trace back to none, and then we re-raise it. So you might expect that this frame that has f in it will not be in the traceback because we wiped it out, right? But it is there. It is there because we wiped out the traceback that is on the exception. We didn't touch the traceback that the interpreter thinks is the traceback, which is the 3rd item in that exe info. So this is a bug that you probably never noticed. I think it's a bug. Nobody ever reported it as a bug, but I think it's a bug. And so what I did over a sequence of delicate pull requests is to remove that redundancy, and it was all over the opcodes. Like, so this is the re-raise opcode. This is like take the exception from the stack and raise it. Whatever exception is now on the execution stack, just pop it from the stack and raise it. So it would pop 3 items from the stack, do some stuff to build an exception, and then go to, hey, we're raising an exception. So this is what it looks like. So now it just pops 1 item from the stack, and builds the exception, raises it, and it takes the type from the object that it popped from the stack. It takes the traceback from there and raises it as before. And this kind of change, there were a number of opcodes that have to deal with exceptions. For instance, the opcode that handles exiting from a context manager when an exception was raised. So that had 2 exceptions on the stack. So there was like 3 items and 3 items. So you go to the place 8 and do something, and it was a very complicated opcode. So now it's much simpler, and that made raising and catching an exception about 10% faster. I just explained to you how that it doesn't matter that it's slow, but when I make it faster, it does matter. So I'm not consistent, but it wasn't so much about making it faster. It was about simplifying the code, because the code was very complicated in many places in a way that is not benefiting us. And so now, this triplet, this type value traceback, it kind of leaked everywhere in the language. It will take some time to really clean it up. We already have sys.exception that returns just the exception. You can use that instead of exeinfo. So you don't need to use exeinfo anymore. Exeinfo just builds the triplet from the exception. So it's kind of, it doesn't have the triplet anymore. It has to construct it just to be compatible with the way it worked previously. And in the C API, we have the handled exception and get and set for the handled exception instead of get exeinfo set exeinfo. Then there are a bunch of standard library APIs that take exe value TB, and for a while now we've been moving to this kind of hybrid situation where if you just give it an exception instance and then none and none, then or these things default to none, then it will just use that instance, and if you give it a triplet, it will do the right thing. So we have that in the library in a few places. The hard case will be the callbacks, like the dunder exit on context managers. So you write a dunder exit and to change or accept hook, and your callback is supposed to expect the triplet. How to get rid of that is going to be I don't know. It's not clear how to move away from that. So we're going to see this triplet still in dunder exit in places like that, but we will see it less, and hopefully we can find ways to move on. So those were the those were kind of the main changes and exceptions. There's also Pablo will talk about his pride and joy, which is the improved location information on Traceback, which is also related to exceptions. So, but he will cover that.
Excellent. Thank you, Irit. Someone told me while you were delivering this talk that if you Google PEP 654, the first image hit is a picture of your face.
Is it?
Yeah, which is a fun exercise. And
Nice.
and I also wanted to give a quick shout out. You mentioned the Real Python article on this, and if I'm not mistaken, that was written by one of my countrymen, Geir Arne Gjelle.
It was, yes.
He's
Yes,
a
thank
great
you.
writer. I met him a few times, and he's a very nice person. I
It-
think
it-
that
It was a
goes in-
fantastic article. He really he was paying attention to the development process. That was nice to read. Like somebody kind of goes, he didn't just read the docs and summarize them or paraphrase them. He actually looked at pull requests. He was following discussions. It was really a joy to read that article.
Yeah, and I think that it starts also talking about some of the other features of 3.11, so might be an interesting read for anyone here. Cool. Do we have any questions for Irit? Poikea says, how costly was try except for, in 3.10 for cases where no exception was raised?
Oh, I don't have a number off the top of my head. Maybe Mark does. Like what was the kind of performance improvement of zero cost exceptions? It's a good question.
Okay. Maybe we can come up with a number and deliver it into the chat later.
Yeah, I'll try to look it up.
Nanonym says, so is sys exe info now actually deprecated or just discouraged?
It's I couldn't deprecate it because there are all these APIs, like, where you need the triplet. So it wouldn't be nice to deprecate it. But I think what I wrote in the doc was that it's a legacy API and you should use exception unless you actually need that triplet to use another legacy API.
All right.
There is no, all it does is calls sys.exception and then takes the type and the traceback, creates the tuple and returns it. That's all it is. So if you need that tuple, then use sys exe info, but if you don't, then don't.
All right. So it's not going to be deprecated the way that some features had the deprecation exceptions or like the warnings coming up for a few releases and then they were removed.
It's we can't deprecate it unless we have a straightforward way to live without it. And it's going to be a bit tricky to get rid of some of the places where we still need it.
Okay, great. We also have a question. What do you see as the most useful kind of information for exception nodes?
So the use case in hypothesis was you run a test on many inputs, and some of them raised exceptions, and now you want to report the exceptions along with which test generated this exception. So it's this kind of context information. What was I trying to do? Right. So the rule of thumb is it needs to be information that was not available when the exception was raised. It's only available after you caught the exception, and it's kind of relevant to the exception in your application in some way. So, it probably will show up most often when you have an exception group and you want to group exceptions, but annotate each of them with some extra information. But there might be other situations where you want to enrich an exception in some way after you caught it.
All right. Are there any more questions? Probably not. All right. Okay. Thank you, Irit. And let's check back with Pablo. How's the release going, Pablo?
Hey, what's up? We had a big problem, but now it's gone. So we don't have it anymore. I won't say what the problem was because it's a bit embarrassing. Anyway, so we are still waiting for Steve and Ned to publish the artifacts. So the Windows ones, they are almost there. They are now just testing, and after that, they will be just published to the Windows, the Microsoft Store, and the Nugget.org and Python.org. So probably just 5 more minutes. And I don't know about the macOS, but I assume they are getting there because the process of it mysterious. But I assume we are close because normally they are a bit earlier. But yeah, we get confirmation that they are getting built, so that's good. But I think also it's my turn to talk about some of the cool 3.11 feature, right?
Yeah, I mean, you worked on the release as well, right?
Yeah, so I actually work a lot with Irit and Brandt on the faster CPython. I'm not going to talk about this now because we already have a lot. I particularly work quite a lot more on what we call inline Python frames, which probably is a horrendous name because the thing that comes to mind when people hear inline Python frames is not what the change does. But maybe we have time. I can talk about that later. But apart from general, PRs and improvements to error messages and things like that, as Irit mentioned, my pride and joy of the Python 3.11 release is better tracebacks, and I'm very excited to talk about it. So let me see if I can just share the screen. Whoop, not that button. 1 second. Okay, let's see if this works. Can you see the slides?
Yep.
Okay, right. So this is a very kind of interesting change. This, many people may say, yes, okay, it's cool. But for me, I think it's a fantastic improvement. So we are super excited for you to use it. So let me introduce what it is. So this is basically PEP 657, which has the horrendous name include fine-grained error location in tracebacks. I know it sucks. We are really bad at naming, which is consistent because I'm a physicist and we all physicists are extremely bad at naming. Like, come on, dark matter. I know it sounds cool, but it's not really what you think, right? It should be called invisible matter. Anyway, so in the spirit of being bad at naming, I added this name to the PEP, so I'm the only person to blame here. But the other two co-authors of this PEP, and actually they help a lot in the implementation, are Amar Askar, that's the image on the left, and Batu Hantaskaya, that's the image on the right. As I never know which picture people prefer, I just pick these drawings that they have in the profile, so probably they won't be mad at me for choosing bad pictures. Okay, so if you want the technical details and all the boring stuff, you can just go and read this PEP. I'm going to just show it to you. Okay, imagine the following, right? You arrive to work or to university or whatever, 9 a.m., too early in the morning, and then pass, and there is like an error, and then, you get the adrenaline rush, what's going on, and you log in to whatever log system you have, and you find this, right? It's just an example. Apparently, your company, according to this traceback, does some Manhattan distance calculation, super important. But then suddenly, this thing is subtracting 2 points to calculate the Manhattan distance, and the error says, non-type doesn't have attribute X. Or no, some of these points is none, but you don't know which one. That is horrendous, because if only Lemon, if only you could know which of these points is none, you could solve the problem. You will be crowned as great developer of the company, and you will have all riches. But for that, who knows how to fix this, right? Like, you will need to touch a debugger, rerun the program, impossible. So now, thanks to the extreme power of Python 3.11, now this error will look like this. Wow, incredible. I hear people clapping in the chat. It's really possible, but I'm hearing them, because now you can be that developer. You can win the day. You can see that, point 2 is the one that is none. And now you can even like trace it through the code and see like, oh, okay, point 2 is none because someone, I don't know, complete the story here. Like, choose your best possibility. And that's the idea. The idea, as you can see, is that now Python will point you to where the error happens. It's not only when you have attributes that go wrong. Like, for instance, let's suppose this other example, right? Same company, another day. And it's doing a bunch of things, not very important. But as you can see in the last line, there is this response, which is some JSON. And you access a bunch of keys in the JSON, and damn, non-type object is not subscriptable. Again, no bueno. And what happens? Which of these keys none? Some of them is none, but you don't know. So you will need the entire message. Isn't that horrible? But look at this. Python 3.11 has a trick, and is that now I will show you. Oh, is that one? That one is the one is none. And this is fantastic. So now you don't even have debugger. Debugger are for losers, not real sentence. But now it's fantastic. It's great. Now you know that C is none. Probably the developers will also fix those key names. ABC are not great key names, but C is the wrong one. And the idea is that this works with everything. Like, for instance, you have this super complicated mathematical expression. It will tell you which one of these is 0. In this case, is this one. So you can see, okay, when Python was trying to divide Y and Z, then that division failed because Z was 0, which is great. Now you can know which one it is. And this works with everything, right? This works with the standard library. This works with third-party code. Absolutely everything, no problem.
Well, Pablo couldn't...
Go ahead.
No, you're right. Z is 0. But, it's... No, because it's on the right side of the operator. I was going to say, couldn't Y have been 0? But that doesn't really make sense.
But then you see what happened here is that the Python does the calculation X, Y, Z as division, right? And the whole operation is 0. So technically, sorry, the whole operation is not 0. The division is 0 on Z. So here you can see all the squibbles, or whatever this is called in English, the tilde. All the tildes here, they cover also X and Y. The reason they call X and Y here is because what happened already is that X and Y were already divided, and that result is the one that is being divisible by Z. So that's why you get all the line being underlined. Technically, because the way the order of operation works, if you have a line that is underlined fully, the thing that fails is the last one, because it's the last being operated unless you have parentheses. But here we showed you with this little hat, which is something that Batuhan worked a lot to do correctly. So with that little hat, we showed you this one, so you don't need to guess. But yeah, as you can see, the line extends to X and Y because X and Y has been already divided. That's the reason it happened. Okay. So how is this happening? How is this possible? Which kind of like witchcraft is being involved here, or like computer science? So let me tell you, it's very interesting. So as you know, Python is a bytecode machine, or at least Python. Most Pythons are, and it works on bytecode. So for example, this is the bytecode of that horrendous operation. It has a long name because it says, oh, I need to put this the content of this variable in somewhere. Then it loads the constant for A, B, and C that are just strings. And then after every of these loads for the strings, it does this operation called binary subscript, which is basically like access the element A into the object that is on the stack. As you can see with this module, you can see the first column is the index of the operation, if I know bytecode, if I'm not mistaken, and a bunch of other things that is not important. So the way we do this is that you can actually check what is inside these things. But the way we do is that we attach positions to every of these instructions. So for instance, now you can use the existing method this.get instructions over the string, and it will give you a bunch of instruction objects which has a lot of stuff. But like among other things, it will have now this positions thing. And this positions thing is basically a tuple of 4 numbers. Is the line number the instruction starts, the end line number the instruction start, the colon offset, and the end colon offset. So the reason you need 4 is because you can have instructions that the code that generates said instruction actually spawns multiple lines, and maybe not the whole line. So it may start at an arbitrary point in one line, and it may be ending in an arbitrary point in another line. So we would this set of 4 numbers will tell you is where it starts and where it ends. So you can basically reconstruct from that which part of the code is that, right? And the way we basically use this information is we're using this horrendous C code is horrendous, and it's very big and nobody likes it. But as you can see, we have a nice diagram and things. But like the magic of Python is that the suckers that maintain the language needs to care about this, and you don't. It just works. And if it doesn't work, you can report bugs, and we will do our best. But you don't need to work with this insanity. It's not needed. You just need to clap or whatever and say like, nice work, core development team. In particular, we all work on this function. I think like the AST part is done by Batuhan, but the rest is done by Amar and myself. Well, actually, I think we all work on everything. Anyway, you don't need to care about this. It's just that it's ugly, but it works very fast because it's C, the fastest language on earth. Anyway, I'm not going to take questions about that statement. So the final idea that we use to reconstruct the nice error location is that you have this piece of code, and then we get these instructions with positions, but we also take the AST. The reason we take the AST is because, as you saw, there were like a bunch of different characters in the error. Like for instance, sometimes it points you to the dictionary key that is wrong. Sometimes it points you to the binary operation that is wrong, or the attribute or whatever. So to do this special, highlighting, we take the AST of the expression, which we can because we know the source that generated the AST, because we know from the positions where it starts and where it ends. By the magic properties of the Python language, that is always parsable, or almost always. And if we can parse it, that we analyze the AST and we say, oh, actually what failed is a binary subscript operation. So we are going to try to highlight the key in the dictionary that it was wrong. Or what if failed was this binary operation. So we are trying to highlight, the operation across all of the possible operations that was wrong. So using these two together, we combine it, and voila, you have this incredible and fine, things, which is awesome, fantastic. I'm super excited about this. It's probably the best feature of Python 3 by my humble opinion. So sorry, everyone else.
But very humble.
Yeah, I think it's cool. So yeah, probably Batuhan and Amar are in my camp. But anyway,
I feel some degree of deja vu here, because I believe in 3.10 you also introduced some improvements to the exceptions.
Yes, but they were less exciting. They are very exciting, but less than this, because this is new. The others are old.
That's right. Yeah. But last year it was something about the syntax errors, showing exactly how the syntax broke. Was that it?
Yeah, so last year we introduced a lot of the better error messages on syntax errors. So it will tell you kind of like what is wrong if you mistype some Python. But we will also introduce like, did you mean on, type errors, type errors, attribute errors and name errors. Which, by the way, I was making these slides and I mistyped something, and then it says, oh, did you mean Manhattan distance instead of whatever I wrote? I said like, wow, yes, I meant that. Thanks, Pablo from the past. Great great stuff. So yeah, yes. So this is a trend that that we started a bunch ago. We tried to improve the error messages along everything, and this is one of the things that we wanted to introduce. And there are more things in 3.12. I won't disclose which ones because we are working on those as we speak. But well, not maybe I will speak now. I'm working on the release.
But I was just about to ask what you had planned next.
No. I'm not double working on the release, and new error messages is fine. We have the Windows binaries. Wow, we are just missing the macOS ones. Cool.
I will add though that while this might seem a little bit minor to some people, as someone who runs an educational community...
preposterous. What do you mean a bit minor? Sorry.
As someone who runs a big educational community, this is a huge game changer for us, because this is the kind of stuff that trips up beginners. they come to us and they don't understand the exception. They don't know which of the things failed, and something's ambiguous, or they're looking at the line instead of the line above. These are like super typical things, and you're kind of eliminating these beginner pitfalls by improving these messages. So I think it's a huge favor to especially the large biomass of new developers who pick up Python as their first language.
Thanks. I think the same. Like one of the things that makes me very happy is all the people teaching Python telling me that all these things help a lot. And I remember with a lot of happiness when I was in PyCon, and I had a lot of educators mentioning, "Oh wow, the new error messages are making a difference in my class." By the way, if you allow me to do something to clarify something very small, so Thomas Guterres, probably sorry, I think I missaid your last name. Anyway, Thomas, the release manager of 3.12. Now that we are arch nemesis or something, he's pointing out that in this example that you are seeing right now, we are technically transforming my dict ABC into our division error. So that's obviously not what is happening, Thomas. I just mess up copying the slide. But yes. Just to be clear, we are not magically transforming dictionaries into divisions. But thanks. So thanks for noticing that out, Thomas. Anyway, just to be clear, so people don't put into hundreds of newsletters tomorrow. Core developer mess ups and transform dictionaries into divisions. No, not happening. Cool. Just another note from this very quickly. So this involves some extra space, because obviously we need to put the extra information in all the instructions, and that takes a bit of the space. It shouldn't be a lot. We measure that the code objects get a bit bigger, but the code objects are not really most memory in your application. But sometimes you care about it, right? Like, I don't know, maybe you run hundreds and hundreds of applications, and then you care about the difference. So there is two ways to deactivate this. There is an environment variable, and then there is a specific flag that you can pass to the interpreter. You can find those ways in the release notes and in the documentation. I think it's not the bug ranges or something like that, and not the bug ranges with -x. The important thing for you to remember is that if you, for whatever reason, don't really like this thing because you find it noisy, there is a lot of different people. Some are better and some are worse. But if you find it noisy or something like that, or you care about your, the space in your hard drive or on your RAM, you can always deactivate it. And if you care also about the size of your PYC files, because obviously this information ends in your PYC files, you can also use the magic deactivation, and it will create PYC files with no information, and therefore it won't appear later. But yes, you can do whatever you want. We give you the option.
Very cool. Will you also say a few words about the new toml library while we got you?
Yes. I will say a few new words. I wanted the first thing I'm going to say is that I wanted to prepare some slides, but then I went into all these release problems and I didn't. So I'm going to say it by voice, I suppose, and not slides. So we have a new toml library in the standard library. This, unsurprisingly, allows you to parse toml, which is the language that is used by project.toml. What a revelation. So this is quite important, because like a lot of people care about parsing that specific file, and probably many more is written in toml, like you apparently. And that is important because nowadays a lot of configuration goes into the project.toml, right? And different tools care about doing this, and all these tools at the time, like in 3.10 and before, they need to import one of the toml libraries and then parse that file, which is a new dependency, etc. So now we have toml. Just very important, the library only has, I think, two functions. One of them allows you to load toml from a file, and the other from a string. Obviously, one can be reimplemented with the other if you read the file. They don't allow you to write toml. So you cannot just pass a dictionary and voila, here is some toml. No, that doesn't happen, because writing toml is a tricky business, and the moment you are read and write, people suddenly want round tripping. Wow, that's nasty. No, we are not adding that. So only reading toml for now, and probably for a lot of time. If you want the other APIs like writing toml, you can reach to one of these libraries that allow you to write toml, and file bash about round tripping to them. But yeah, we are quite happy to report that now you can read toml files without third-party dependencies, which is very cool. We like it. That's where we added it.
That's very cool.
That has a picture as well. I don't remember the
If
number.
someone can hear manic banshee screaming in the background, it is my 5-month-old daughter. That's what she sounds like. 14 hours a day.
It's fine. There was also fireworks here where I'm living, and I was like thinking, wow, man, people are getting very excited about the release of stream. But it's probably not for right. It's probably some football or something.
All right. Cool, Pablo. We've got a question from XCanG. How custom exceptions can access these positions, if it is possible at all?
Yes, that is an excellent question. So yes, you can. There is an API for tools, because actually this information is also useful for other things. I think I was very busy on the release, so I don't know if this is true, but I think Brandt showed you this tool that he did for showing the part that Python is faster using the optimizations. That happened? Brandt, can you confirm this? Well, anyway, there is whoa. Oh,
Yes.
hello,
Yes.
Thanks.
Yeah, Specialist uses PEP 657 in a totally unintended way to get that column level highlighting.
But oh boy, was I happy when you told me. And I said, I foresaw this. I knew this was going to be useful for more than exceptions. And it was. What a nice day.
Yeah.
Right.
I'm just waiting till someone inevitably asks for like column level coverage or something horrible like that.
Right. I mean, this is important because like other tools can leverage this information. So yes, it can be accessed through Python and C. You can use C and Python to access this information from call objects, and then you can use the exceptions, I think, or tracebacks, or one of the two have an instruction offset that tells you it will tell you the instruction that failed. And knowing the instruction that failed, you can go and check the instruction and the positions. The API, I think, is called co_positions or something like that. It gives you a generator of 4 tuples in Python. In C is some monstrosity with pointers. I don't know. Don't just see if you can. Although it's a fantastic language. Anyway, the important thing is that it's useful for other tools. Like, for instance, we thought that maybe coverage tools may be interested in this as well. Because, for instance, you can have a line that says X equals something if something else another thing. And, it will tell you if you are highlighting the line as cover, because coverage works by highlighting the line. It will kind of highlight the whole line, but then, there is 2 branches there. I don't know exactly what coverage does. I'm sure that Net finds some cool pattern to solve that problem, but maybe no. So now with this, you can know exactly which part of the line is covered and which part is not covered. Imagining that one of the branches was never taken. So now you can highlight better. So coverage is one example that we have in mind, but any tool like a Specialist, for instance, can access this. Very good question.
Great. Scott Noyce asks, is this accessible if I wanted to, for example, pick a different care or make it change color?
Only if you re-implement the whole thing. So no, you cannot change the characters or the colors. But if you are implementing so it's accessible. Sorry, it's also implemented on the if I recall correctly, on the traceback module. So you can import traceback, and I think it should do this. If not, we are adding that to 3.12, or we are backporting it, depending on different things. But you need to re-implement it in terms of the traceback module or do it yourself. So the information is there. Actually, it's very easy once you have the information. So you have your own custom, exception displayer function. You can add the information very easily. It's just 4 or 5 lines. But then you need to implement it. We don't allow you to change the color or the character or add color. I suppose IPython, for instance, I think is going to have to do that because they have their own exception handler thingy. And probably they don't want to add the underline. They are going to use like bold letters or colors in lines, so it doesn't occupy a new line, because that's kind of a disadvantage of this, that it will show you more lines on the screen.
And are there any plans to add this to the REPL or -C argument to Python?
Maybe there are some plans, but they are now stopped. We had a prototype, but the problem is that the REPL doesn't. Well, there is a lot of interesting things with the REPL. For instance, there is no REPL. Wow, what a revelation! There is no such thing. There is only the parser. So when you are writing Python code in the REPL, you are really in the parser. So there is no REPL module. You try to find it, there is nothing. So that is quite difficult. So the problem is that when you type something in the REPL, there is no source. Because as you type it, the parser just takes the tokens, it just does its thing, and you produce call objects, but the source is gone. So we are thinking about trying to save it somewhere, maybe some temporary file or something, or to add it to the code objects only in REPL mode. We found all of these things very intrusive, and we don't like it, so we didn't add it. But if many people ask for it, we may reconsider. But honestly, at this point, we probably need to uncouple the REPL from the parser and do it properly, properly.
Yeah, maybe. Cool. All right. There's another question. Is the test pipeline publicly visible for us people with short attention, which feel need to hop between it and presentation all the time?
The test pipeline.
Was that
Do you mean
the thing that you showed earlier with the steps?
Yes.
That beautiful thing.
I think it is. Let me double check.
Either that or it's the build bots, but I don't think it's the build bots. I think it's the other. It's
the Windows one.
The Azure Pipelines one, right?
I added it to the stream so someone can paste it on YouTube. It's in the stream chat.
Cool.
So by the magic of the organization, someone pastes this on the chat. I think it's finished. I think it's finished. Not much that you can tell. Let me check if it's finished. No, it's not. No, yeah, it is, because I said that the Windows one is out there. We are still waiting for the macOS ones. So yeah, there you go. The pipeline is there.
Okay, cool. Right, should we hand it over to Łukasz Langa then for some information on the new typing stuff in this release? Hey, Łukasz. You're muted.
Okay, cool. Let me see if I can present. I can, but not the screen I want. Let me just switch the screens over. Okay, that looks better. Okay, can you see the thing? Okay.
Yes, it looks good.
All right, cool. So let me switch over to PowerPoint. Hi, I'm Łukasz. I come from the internet. I'm in Poland right now. I am the release manager of super old Python, so like totally non-interesting at the moment. And I'm the core developer in residence since last July. July last year. This has been like a dream come true for me. Like, it's an awesome job where I can work on Python full time. I spent this time mostly doing like janitorial work, like, reviewing pull requests, like taking care of bots that are down, and still doing releases. Every now and again we have some security fix that needs to be included. So when we gather enough of them, or some is severe enough, like, we would do a release. So I do that. And there's a bunch of other like things that I do. For example, just 3 weeks back, we were in Sunnyvale for a core development sprint. I just wrote a blog post about like what we did there, and like why those sorts of core sprints are important. So you can read on that on blogpython.org. But today we're not going to be talking about this. We're going to be talking about Python 3.11 typing features, and there's very many of them. But I know that like if I start talking about like one complex one and you're gonna be like, what are you doing? Then I'm gonna lose you. So we're gonna start with some simple ones, like, just one slide each, just to show you like, oh, this is an improvement, this is an improvement, and just move to more complex ones. Because I wanted to cover like all the big ones at least, but then I actually kind of listed everything that is there that I'm aware of, just for the, few typing enthusiasts that might be watching right now. yeah, because PEP 484, as created in, what was it, 2014, 2015, it got a lot of basics right, but a lot of kind of niceties that you would get if typing was added to a new programming language couldn't be added initially. And the reason why was that Guido and other contributors to the original PEP thought, what if this actually doesn't work out and people hate it? And, maybe this won't actually get much adoption. In this case, you cannot really change the language, change the syntax, and start providing, changes to how Python behaves at runtime just for this feature, because we don't really know whether it's going to be popular yet. Well, in turn, over the releases since 3.5, it got pretty obvious that it is a value. There is a large subset of Python users who are using type hints for their daily work. So now there are a bunch of PEPs and a bunch of smaller changes that address some day-to-day complications that people just find in typical or less typical typing usage. And some of those that we're going to be talking today about are in fact pretty kind of edge casey, but they're very important edge cases if you are one of those people who get hit by them. So for example, a very simple PEP here is 655, where we can now say whether field on a type dict is required or not. And in the slide, I took two examples from the PEP where you can either say that what I'm telling here is not total, so total equals false, so there might be other keys, but in that case, you can now specify that, okay, it's not the total thing, but this one thing is required. So for example, in the movie example, the title is required. You can say the same thing by just saying that the title is just a field and then another field is not required. The type checker will know, looking at this syntax, that oh, okay, you didn't say total equals true, but you specify not required fields, meaning all the others are required. So you can, depending on what makes better sense for humans, you can decide on this or that. It is a pretty usable feature for day-to-day usage, because otherwise you actually had to either have 2 lakhs of an error checking, where you didn't really know whether some keys are going to be entirely invalid and not passed, or you were unable to accept extra keys. Now this is solved with this PEP. Another case that kind of sounds maybe abstract, but is incredibly important when you're running some service on the internet, is that certain data coming from the user might end up being executable instructions, for example, SQL or another programming language or something. And this is extremely dangerous because that user might be malicious, and that user might actually put some Bobby tables and delete all your data or access data that they shouldn't be able to. So now with PEP 675, what we can do is say that, okay, this field is a string, but it's not just a string, it's a literal string, meaning it's just a piece of string from the code base. It does not come from the user. And doing this would be easy enough, but that would be incredibly inconvenient because we want to forbid harmful execution of user-controlled data, but still allow some benign idioms, right? So, for example, if you're doing just addition of literal strings, that should be fine. Like in-place addition, like in the example, same thing. If you're joining only using literal strings, that should also be allowed. And if you're formatting strings using only literal strings, that is also safe. So the PEP goes through a bunch of examples like these and defines what a literal string is and what operations on it are allowed and what mixing with regular strings does and what mixing with other literals. Because previously you couldn't really say an arbitrary string is literal, but you could list a bunch of literals. For example, when you are opening a file, like there are only a few combinations in the mode, right? There's going to be RB, there's going to be R text, right? There's going to be appending, there's going to be write B, and so on and so on. So there's only a bunch of them. So you could literally list them all and say, these are the allowed values. But for queries, that's not really possible because there's just too many of them. So literal string solves that issue. Self-type is another relatively simple idea, but there's a lot of kind of, nitty-gritty details in the implementation there, where before it was also possible to have a method on a type that returns an instance of itself, or maybe returns the class of itself, and so on and so on. It was pretty tricky to actually get it right. And the reason why was that if you inherit from a type, then you need to really be careful about the types in the base such that this always stays correct for the type checker. So for example, like if you have like this totally bad example that is like shape, and then you have a rectangle, and then you have square, like if you define on the shape that something returns a shape, then that return value will always be a shape, even if you are returning rectangles or squares. So that's wrong. Now with the special self name, we always return an instance of the current type that we are at, even in the face of inheritance. And this is doubly interesting if you have things like here we have type variables. Like we could do this before, and this was very ugly. Now like we have the self object that also works on class methods, right? So not only like regular methods work, like this is handled perfectly fine for this. And you can still use type self to denote that what you're returning is a class. So like all's good. Okay, now we're moving to like a tricky PEP, data class transforms. So what I'm going to do now is I'm showing you the end result, what you're going to see as a user of this, because this is the point. Like what we want to do is if you have data classes which you like, you might have some custom decorators that create data classes or something that looks like a data class but isn't, for example, using adders. And you might not do this statically enough for the type checker to understand that this is still a data class, because for now, MyPy literally has some special handling for data classes to understand that data classes take the fields from your definition and auto-generate a bunch of methods. So MyPy needs to actually implement this to know that, oh, it shouldn't raise a type error when you're creating an object with a bunch of keyword arguments. So this is complicated enough, but if you are doing some indirection, like in this case, we have some create modal. It's not a regular data class, it's something that inherits from it. Like, how do we make this work with type checkers? So now, in typing, there is data class transform. Like, this looks complicated, and it has to be, because it has to be flexible, but it's not something you're going to be writing every day. You're going to be the user of this. Like, the end result is going to be that now type checkers are going to understand more complex code generators like adders built in, right? So data class transform in this example, like for example, says that you only can have keyword arguments in under init, and there's some field specifiers. So if you're specifying custom fields, it understands what the generators for those fields are. So in the previous slide, you had like this ID is an integer, and there's some modal field. Again, it's not just a field from data classes, it's something custom. But there's some resolver. What is it? Well, what now? Like you can specify that, oh, this field specifier is this function. And that function can be just a regular Python function, but it can also have overloads, a feature that we already had for typing, so that you can really tell it like all the possible variants that a model field can possibly have that are valid. So yeah, data class transforms looks really complex, but it will allow you to just, use types in cases that are more dynamic than you would think. And finally, for some case that is also pretty dynamic, shapes of arrays, something that NumPy and TensorFlow care about quite a lot. Before the slide that you can see here, you could only create an array that had 1 dimension, or maybe 2 dimensions, or maybe 3 dimensions, or maybe 4 dimensions, if you wanted it to be generic. Like you could only say like A, B, C, D, like, maybe 1 dimension, maybe 3. But now you can specify an arbitrary length of those dimensions, right? So you don't have to say this right away. You can just say star shape, like in the generic constructor there, in the generic base right there. So in the example, you see some height and some width. Those are just ints, but we specify that they're different types just so that we know that they're different axes, right, on our type. And we have 2 example types annotated on the last 2 lines. So there's X, which is just an array of height and width, and there's an Y that is an array of height and width, but prepended with some batch, right? So it's a very cool thing about this is not just that now you can do this very, because again, like the generic star shape looks kind of ugly, but this is not something you're going to be writing. What you will be writing is this array instantiation when you specify the dimensions of an array you want to use. So what will be possible now is just a very handy syntax for just you decide what shape that this array has depending on your data. But what is cool is the type checker will now also be able to differentiate between 2 different arrays, even if they have the same number of axes, but they're not the same axes. For example, if you have this X, which is an array of height and width, you will be able to say that some Z is an array of width and height. And the type checker will understand that, oh, okay, they look the same, but they're not. Operations on them will be sometimes correct, because sometimes you're only going to be operating on one of these axes. But if you're just trying to just, I don't know, concatenate them or whatever, it'll tell you hey, those are not compatible. So what you're getting from this is essentially an ability to now avoid some errors before running your code. And this is what typing was in large part created for. So yeah, an interesting thing is so you have this star shape, so how do you use it inside the class that has this variadic shape? So this is one example where you just specify the shape as a tuple. That shape is given you as an init argument, and here you specify it when you're creating the object. So obviously NumPy has some different way of doing the same, but now we can integrate those things. Okay, so those are the PEPs. Quite a few, but as you can see, every one of them is pretty much a single feature that is going to be used by some subset of typing users. Some subset relies on my baby single dispatch, and now you'll be able to specify unions when you are registering functions for single dispatch. That was kind of possible before if you just applied multiple decorators to a single implementation, but now this is more in line with the rest of typing, so it's kind of handy. It looks much nicer if you do that. Obviously, int or float is maybe not the best examples, because in the numeric tower in typing, float is going to include all ints. But the point being, you can actually use unions now, so good. Speaking of some babies of mine, well, what about PEP 563? Is it the default in Python 3.11? Well, no, it's not. And since we have PEP 649, which looks like it's actually a better idea and more elegant solution, computer science-wise, kind of programming language design-wise, we might end up, there is no final decision yet, but we are all, I think, leaning towards accepting PEP 649. Like, I will leave that to the steering council to kind of, communicate later. But from my discussions during the sprint, like, it turns out that, like the from future import annotations will still live for at least a couple of releases, but it'll very likely never become the default. Like, I'm not kind of empowered to say that for sure that will not happen, but very unlikely. Okay, so quickly, let's go through some tiny typing changes to maybe just finish on a positive note, because now it's somewhat of a downer, especially for me. Like, I just put some feature in Python and now it's going to be ripped out like at some point because it's turns out not to be the best solution for the problem. So let's move on. Let's forget about this for a second. A bunch of edge cases that were not supported before will be now behaving better inside Python. So if you are using Dunder complex and Dunder bytes, now they will actually supports complex and supports bytes protocols from typing. This is useful for more detailed typing of numeric operations. And similarly, if you have fractions, they have an Dunder int method. So like, again, you can use supports int for as a check, and that will work right now. So the next slide is literally just like ELS changes. So ELS Istra is like a super prolific typing core developer, and a bunch of small changes like were implemented by him alone. So like add typing assert never, typing never. It's something that, like, in hindsight looks obvious, but it only looks obvious when you already did it. Just typing never is saying that, you will never return, like you will never get into some place of the code. It's just a much better name than what we had before for this. It's just no return. Reveal type is something that MyPy always gave you, which is what type does this thing have? But it was extension that just MyPy implemented just for your own debugging of what happens. And other type checkers might or might not implement this, like usually all of them do, but there are differences, right, in how they do this. So now there is actually typing reveal type, so you can actually ask, and everybody knows what this code is if you ever check it into the repository by mistake or whatever. And yeah, you can also assert that something is of a given type. There's a typing final decorator, and you can actually get overloads from a function, which is super useful for knowing what possibilities there are for valid signatures of a function. You can now list them, and you can even clear them, which is very interesting as well. And other changes by others, since like there's quite a crowd right now in terms of typing maintainers. So a bunch of things like name tuple type dict were made generic. Now we can subclass any, which actually it turned out like it makes sense, which appeared to us very late, to have an any that is a little more constrained. Like for example, you have a mock, so you might say that this is a mock, so it accepts anything. It's any, right? Well, but the things that you're actually mocking, that you care about, some method on the mock, you really want to type check still that the usage of that particular method is correct. So if you just say any, it'll allow whatever. So now you can subclass any, so if you create a mock, in such a way where if you just hit it with some random field that it doesn't know about and random method, it'll just not raise an error. But if you misuse a specified method, you will still get an error in the type checker. So that's good. Yeah, I think like we're kind of at time right now, like for me to list everything else that is happening here. Mostly get type hints became more usable as well. And we had a bunch of deprecations, like typing text was only needed for Python 2 and Python 3 compatibility. It's time now to just say, that's no longer really necessary. Please use just strings. And same with the keyword argument syntax for constructing typed dicts. It was pretty clunky and limited, so that is deprecated right now as well. Okay, that's all I have for now. If you have any questions, then I'm open to answer them as well.
Excellent. I think we do have some questions. Let's see if we can get them up on the stream. Anton Agastam says, will there be another Dunder future for 649?
Well, yeah, so the PEP currently specifies that there would be another future, but that would create like a terrible, terrible transition period. Our thinking at the moment, which will need another round of discussions like publicly, like on discourse, is that probably we can just get away with accepting PEP 649 and just putting CO annotations, the result of the calling that function, like in annotations by default, because the semantic difference between them is small enough that we can probably just stomach the backwards incompatibility, because it's much better to just say, oh, if somebody is using from future import annotations, you're still getting strings. That's this kind of sideways feature. But if you didn't do anything, so your code previously was eagerly accepting annotations, eagerly evaluating annotations, now you will get those like almost eagerly evaluated annotations because they have the closure and they can evaluate pretty much the same except for very limited cases. Like that's the point where like Larry Hastings came up with some ways to mitigate some edge cases that previously existed in the PEP. I don't think the PEP was updated yet to reflect those ideas, but like with everything that we talked about, like it seems sensible to just accept it and just change the behavior, since like ironically that actually allows for more expressive annotations than before.
All right. XCanG asks, can types actually be used at runtime to validate types? Sort of what pedantic can do, but to functions and variables?
There are runtime type checkers that use PEP 484 type annotations to do runtime checking. And some compilers like MyPyC or the static Python compiler from Cinder by Instagram does the same, where it uses type annotations and it makes things faster for you, like in some C code, but it needs to now, it's not an option, it needs to check whether the type you're passing it is really the type that you promised in the type annotation, because it generated C code depending on this assumption. So yeah, like first of all, the compilers will do this for you, but also there are literally just runtime type checkers. I lose the name like right now, like so I won't tell you off the top of my head, but like there were a few that I kind of learned about, like and for sure like at least one of them I forget the name, like it was even mentioned at the sprint. So like apparently people sometimes want the feature. So yes, it is possible. Some types are less kind of useful for type checking than others. If you have some very generic type that you're using, so for example, you say you have a collection of strings, that's not really something that can be reasonably, runtime checked, because it's kind of very generic. So like yeah, like you can do the is instance, that's it. But like will it really tell you much? Like no. But for a lot of others, like yeah, like it's something that you can do. The interesting part of runtime type checking though is that if you have, say, a collection of strings, then what we know is that, oh, like there's some way for us to just say whether something is contained in it or not, but kind of how do we check that everything that is in it, it's not part of the contract for the container? How can we check that everything that's in it is in fact a string? Because some of them might not be, kind of iterable. Some of them might not be iterable twice. So it's definitely like a challenge for the runtime type checkers to implement. But there exist projects that do this.
Chat suggested bear type and type guard may be the ones you mentioned.
Oh, type guard is the one that, yes, that's the one that we talked about.
Great. Thank you, chat. They've always got our back. Do we have any more questions from chat? Perhaps not.
All right, cool.
Thank you, Łukasz. Let's check back with Pablo. How's the release going, my friend? You're muted.
We are there. Sorry, I just fixed all the weird stuff, but we are there. We just need last thing, so I'm going to just share this part. Let me show you how it looks. So what I'm doing right now, let's see. I think it's this one. Okay, so the release page. So I just all the artifacts are there. I push the tag to the CPython repo. That doesn't make it release though. Like it's just that if you want to fetch the tag that we use for the sources is there. I fix all the merge conflicts in the world. Quite annoying, but it's done. And now I'm editing this page. So this page is kind of the Django server that we use for python.org. And here is basically you need to fill all these boxes in the correct way, otherwise it will crash. I think now it doesn't crash that much, but like this is the release announcement with all the stuff to put typos on. This is where I put the what is this? No. So this is where I put the I don't know if you know it, but like I've been putting this small physics kind of trivia there. So this is where I put all of these things and where people make me that I'm missing links. So I add them here. Where the docs are, and then the script fills manually all the release artifacts and where are in the server. So and description. So this is done automatically, hopefully, but sometimes we need to edit by hand. Very rarely though. So now that this is here, we need to say that we want it to show on the download page, that this is the latest release, and that is published. Hold your breath because it doesn't make it published really. So we are going to save it here. Okay, save, and we are going to check if this actually shows. Nice. By the way, we have this cool logo for 311.
Wow.
So this is
Who
showing.
made that?
A friend of mine is called Mike Jimenez. He made also the previous one for 310 with all the different things that we have. Anyway, I think now we can push the red button. So I share now my terminal. Give me 1 second because yeah, there you go. Big.
Exciting.
So this is the button, right? Okay, there you go. So now I just rerun the script again and hopefully picks up what where, and it's going to check. Whoop, sorry, I was testing something just in the worst moment. 1 second, I think it's here. This is not working. Cool. So technically this will just purge the CDN. And it will ask me, yes, I have done this. And do you want to release Python 3.11? Yes. Whoa,
Hey!
nice. Awesome.
You
awesome.
did it!
Yeah, incredible. No errors whatsoever. Nice. Everybody clap in the chat. This release. What a day, Well, man, I cannot believe that this is done. Man, you cannot imagine there for doing this release and managing it. So it's done. Wow, incredible.
Yeah.
Well, now we need to check. Actually, we need to check last thing, just
Okay.
because last time this failed. So let me share so you can see. Meanwhile, if it fails, my desperation. So technically, the last check is that if I share the screen, we can put it again here. This is the official check to see if it's released. Can we put the share on the screen again, please, if possible? Thank you. So technically, this is what failed last time, but I think now it's okay. If you go to python.org and then you see downloads, yes, okay, now it's here. So it says Python 3.11. It says on macOS because I'm here. if you have a Windows computer, or if Steve is around, can you check that the Windows one shows Python 3.11, because that is what used to crash. And if you're adding a Linux platform, do the same, because this tech is different. Okay, awesome. Thank you very much, everyone checking. We can consider it release. Nice.
Very nice. Congratulations to the team.
Thank you very much. It was extremely not easy. I'm going to
Yeah, I know you've been. It's been an arduous path for you, Pablo.
Yeah, but it's done. Now it's Thomas' problem.
Now it's Thomas's problem.
Now you can break everyone. So I think we can bring everyone back.
Yeah, let's bring everyone back on the stream.
Yeah.
Hello, everyone, and congratulations.
We hardly did anything.
Irit's got
Pablo.
Yeah, it's not true. I have you in my
the champagne,
helping and noticing the errors in the slide. Man, do you know what is funnier? That slide is taken for my talk at PyCon US, and nobody noticed.
That's funny.
And that's embarrassing because I was there and I reviewed those slides as well. So
Indeed. So, maybe you notice and you say, "Man, I know that this guy is going to reuse this slide, so let's wait until there is more people looking."
Wait for the live stream to call him. Yeah.
I'm joking. It's fine. I thank you a lot actually for mentioning. Like, it's not the first time people are by my subpart slide, and then I don't have the opportunity to say it. So thanks.
no, but now, I mean, we were on stage together while you presented those slides, right? So
No. I think you're mistaken. This is the talk that I did myself, not the one.
Okay.
The
because you also showed these slides, I think, or some of these slides at the steering council address at PyCon.
This is true, but it didn't include the technical stuff.
Oh.
So it's just like I saw the exciting part, not like and this is how we make code objects bigger part. So yeah, thanks.
So, I guess, Thomas, now you're officially the release manager. The current in-residence release manager. How's it feel?
Well, I haven't actually done the release yet because I was planning on releasing 3.12 Alpha 1 at the same time as Pablo was releasing 3.11, but I think Pablo was afraid that we would clash and stuff would go wrong in 3.11, and so I'll do it later today. That's when I'll actually become a release manager.
Okay,
and of course, I won't actually be a release manager until next year when we release 3.12 Final 1, because I won't know what the actual job is and the actual difficulty and the stress that Pablo has had to endure over the last year.
You will not know all the stress, but you will know part of the stress when you release Beta 1.
Well. Like the truth is that Thomas once already was a release manager a long time ago. So it's not like he will become one. Like he will just kind of see how it's done these days. But he has some experience that we just don't.
2.1.1, I think we didn't.
2.1.1. Okay.
Yeah,
what was the
didn't release Windows binaries or macOS binaries at the time. Yeah, we had a lot less to worry about.
But what was the stellar feature of 2.1.1?
It was just a licensing change.
The licensing change, wow.
And a couple of bug fixes.
Nice. So yeah, it has changed a bit, just a bit. Now we have funny hats.
Yes.
I hope we are going to
release 2.1.1.
Sorry?
Were you at Google when you released 2.1.1?
No, because this was 2001, so this was even longer ago.
So even your Mueller hat is newer.
Yes.
Man, I didn't show me, but I just freak out middle of the stream. You know why? Because my GPG key and the SSH keys I used to put it on the server is in this YubiKey key. Guess what just broke middle of the stream? This guy broke in the middle of the stream.
You got a spare key though, right?
Yes, I do. I have this other one, which is also USB-C.
Don't break it.
Yeah, and I did the best decision of my life at the time because I said, okay, I have a new one. Should I just copy the GPG key here? Which, by the way, is kind of not recommended. But I said, why I want another one? And I said, yes, let's do that. And now I could save my ass thanks to that decision. Thanks, from the past. Great decision.
Well, you should always have a spare key when you have a YubiKey key. That's but
it shouldn't contain the same GPG key, right? That is not recommended.
Yeah.
It's also,
Thomas, can I have your commitment that as a release manager for 3.10, you're still going to maintain the tradition of silly hats?
Oh, I don't know. I mean, this is such a Pablo thing, and I mean, Pablo is a real showman with his card tricks and his physics facts and the silly hats. I am much less of a showman. I might just show cat pictures, but we can try. Yeah,
No, you need to keep it. You need to keep it.
The release notes have to have something. It can be personal. That's perfectly fine. Yeah, mine did have the snippets from Monty Python sketches, but apparently they were problematic for some. So Well, I'm just doing this most boring releases now, like with just security, serious business. So like no release notes, pretty much like no jokes there anymore. But yeah, like Thomas, you have to have something there too.
I have been told that I need to share cat pictures, so that's what I'll do.
Oh, this is a very good question. Is there any tradition that is passed down from release manager to release manager? Yes, there is a secret conversation that actually you can all learn. You go to the correct place and then you click see source code, but I won't see where it is. It's somewhere on the Python page. There is a secret conversation between release managers.
Wow, nice. That'll take like 10 minutes before the chat has found it, I imagine.
Let's see how fast they are. Maybe you already know them placed it, obviously.
Another question here: how many people are involved in the release?
Well, as many as core developers and contributors and PSF staff and users. Wow, what about that response? Awesome.
Dozens, if not hundreds, then.
Well, I think the important bits are obviously about 100 core developers, although not all of them are active all the time. And then there is one release manager, which was Pablo this time, and me next year. But then there's also the two people who build the macOS and the Windows builds. Hopefully we get more people doing those things, being able to do those things, but they are also pretty critical to the actual release. And then we have the docs building, which is more of a continuous process where a couple of people are responsible for making sure the docs make sense, but also build and print nicely and become PDFs nicely, and translations as well. So there's a lot of moving parts that get managed behind the scenes.
I guess also the steering council that decides what even goes into the release.
Well, the steering council doesn't really do that much.
I mean, we do something.
So Pablo and I are on the Python Steering Council. There's 5 people on there. My coworker Greg, and then Brett and Peter are on there. And we have weekly meetings, so we do spend a lot of time on Python. But we discuss things a lot, and the final decision is supposed to represent the consensus among core developers and the consensus in the community. So it's really the community that makes up its mind, and the Steering Council just reflects that. So we don't make that many decisions.
All right. I think we're going to go into sort of an impromptu Q&A here now. So I'll be asking some questions to the group, and whoever feels like answering, you just answer. How are you planning to solve the issue of delayed releases due to the late release blockers, like what happened with 3.11?
Yeah, Thomas, how are you planning to solve that?
I'm going to rule with an iron fist, and I'm just going to roll back things that break things.
The reign of terror is finished. A new reign of terror.
So, I mean, that's a good warning to Mark and Brandt and Irit is don't break too many things because it'll have to get rolled back. Realistically, I've already talked to Mark about this. Realistically, we should see fewer breakages because a lot of the groundwork has been done. So hopefully we'll see less churn about the internals, and then we're dealing more with breakages in separate modules or smaller scope breakages, and it'll be easier to deal with them. We just have to do a better job. I hopefully we don't run into too many issues in this final 3.11.0 that has been released, because we did run into quite a few in the release candidates and in the betas. But there's always 3.11.1, so we can always fix mistakes later, hopefully.
I mean, we will. There is a bunch of bug fixes that didn't make it into 3.11.0 because, we even if bug fixes are fixing bugs, they can introduce unknown stuff, and this has happened in the past. So that's why there is some bugs that we know that are fixed on 3.11.1 that are not in 3.11.0. Very few, but there is some. If you check the actual difference, there is like 400 commits of difference, or 300. It's just something ridiculous. So yes, but this is just to ensure that we know exactly what we are releasing on 3.11.0, and we know that it's stable, because you may find some weird stuff, and people can test a while these new commits on GitHub CI with using the nightly builds.
It feels inevitable to break things when you're going in and making changes to these deep, dark, arcane parts of the source code. I wish you good luck. So, for everyone to answer, what was your very first PR to CPython? If you remember. I guess it's a really long time ago for some of you.
I remember. My first wasn't so long ago. It was 12 years ago. And it was a fix to config parser. There was a tiny thing in it that didn't work with any files that I was working with, and it turned out that, oh, actually, this wasn't designed like this. It just happened to be like this. So I fixed it, and Fred Drake, who actually was the author of config parser, still hung out on the IRC channel for Python dev. So he just told me what he thought when he implemented it, which was incredible. And when I fixed the bug, like Brian Curtin at the time merged my first patch. It wasn't a pull request. It was literally a patch that I needed to upload to bugspython.org, and then somebody merged it into our SVN at the time.
Yeah.
So I think my original first commit isn't that interesting. I think something on the P2I module. This was in 2000 or so, 2001 maybe. But I'm sharing the screen, so if we can show that share. This is one of the first mentions of me in the Python repo. This was before we accepted PRs, so you had to send patches to other core developers via email. This is Guido mentioning me in a commit message that I thought was amusing, so I've kept this around. Since Thomas kept complaining that he wants access to the Unix from lines, and then details about a small change in the mbox module, which probably very, very few people even know exists. That was sort of my original contribution to Python.
Cool.
Yeah, my first contribution was there's a standard library module called Module Finder, which you basically run it on your source code, and it builds an import graph of all of your dependencies, basically. And I was using that, I think, for work, and I found a couple random bugs in it. So I fixed them. And that PR was open for a couple months or so. I think it was my first PR that I opened, but not the first PR that got merged.
I think for me, it was a missing import in one of the examples in the documentation. Plus, that's not the thing I'm more proud of. We have a file, I think it's called miscax, where there is like, when you contribute for the place time, you add your name there. So that file is sorted alphabetically, but I added myself randomly in the file. And I'm probably the last person, the only person in that file that is not correctly sorted. But yeah, that was chaos was my first contribution, apparently.
Mine was like 11 years ago, and I've just looked at the message, and I don't really know what it did. Obviously, it made sense at the time.
My first PR didn't get merged. It was a test that showed a regression in one of the releases, but then I didn't actually intend for it to be merged as is. But the first one that got merged, I was kind of bored, and I looked at test coverage for the AST module, and I saw that some function doesn't have a test for non-input. So I added the test, and it failed. So I fixed the bug.
Seems like the common denominator is that we all started pretty small. That's probably a good way to get into it, huh?
Or complaining, apparently that allowed you to
Just complaining about stuff might even be enough.
Well, people who know me among the core developers know that I like to complain.
I mean, I think we are close to your to your to your history. Like we like to complain a lot.
Yeah. And while we've been backstage, Thomas has been finding all the problems with people's presentations in the private chat we have. So I think that tracks.
I found 2, so that's not too bad.
So regarding specialization, can you describe how specialization compares to a just-in-time?
Mark,
I guess this is me. Just in time, what?
compiler.
Oh, well,
Compiler?
specialization and compilation are 2 different things, so they are complementary. So just-in-time, generally, just-in-time compiler is often used as a sort of meaning sort of a magic thing that speeds stuff up, which is not really a very useful sort of term. Problem is, generally people bundle a whole bunch of optimizations in with just-in-time compilation to machine code, and then they all get sort of grouped together. So actually just translation to machine code, as I said, is kind of depends on specialization. For a language like Python, it's pretty useless without it. So specialization is the sort of the key that unlocks JIT compilation, I would say.
And specialization does happen just in time. It happens while your code is running. So
Wow.
you can kind of think of it as
Wow.
JIT compilation of bytecode instead of machine code.
Yeah, but is it while it's happening just too late, maybe, or
Just in time for next time you run this instruction.
If specialization constantly fails, will the interpreter give up eventually, or will there be overhead from the constant specialization failures?
Yeah, so Mark actually implemented a change that makes sure that this doesn't result in too much overhead. Basically, it's what's called a exponential backoff. So first, we'll immediately try to specialize, and then if that fails, we'll wait longer, and then if that fails, we'll wait even longer, and we just keep doubling the waiting period until we basically never specialize. Yeah.
Cool. Do we have more questions? Will using type hints help with generation of specialized bytecode?
This is a nice short answer, and the answer is no. And the reason is that we always have better information at runtime than the type hints give us. So there's no point in even looking at the type hints.
Although using type hints might encourage you to write code that is more easily specialized. If you're obeying your type hints and you're sticking with constant types and stuff, then it might be a little more specializable, but we don't look at it.
Can you disable specialization globally to help with debugging weird issues, for instance?
Yeah, turn tracing on, run your code with coverage.
Except that might not work in 3.12. It'll work in 3.11.
No, we don't have like a sys flag that I know of for like turning specialization off globally or anything like that, or like an environment variable.
How many bytecode instructions does specializing cover? Any major ones not covered?
Well, there's a whole bunch of them that are actually the most common bytecodes we don't cover because they don't actually do anything depending on the type. So, like loading a local variable and so on. And then, there are a few we don't cover yet. But I think the main thing is that there are just an incredibly long list of potential specializations for calls and attribute lookups and binary operations and so on. So we're sort of looking into ways to sort of effectively deal with that long tail in 3.12. I don't have any numbers off the top of my head, though.
Yeah, I think
Brandt,
we have like
numbers?
8 or 10 different specialization like families. So there are 8 or 10 opcodes that get specialized. And then we have a few dozen different specializations of those opcodes. A major one that sticks out to me that isn't specialized in 3.11 but is specialized in 3.12 already is iteration in for loops. So the for iter instruction is specialized in 3.12, but it wasn't something we had time for in 3.10 or 3.11 or 3.10.
Will typing be used as error handling or more in depth used inside the runtime in the future?
You're muted.
Thomas, you're
Thomas.
muted.
Thanks. That is not part of the original typing design. And there are a lot of very large hurdles to overcome before something like that will change. And it would need to have significant benefit as well, which I think is arguable for something like error handling. Having a separate tool to check your type annotations is a much lower barrier of entry than baking it all into the interpreter. And it allows way more rapid evolution of the tools as well. So we can't rule it out, but it's not going to happen in the near future.
For Pablo, are there any changes to the Python core language you wish could be made for physics computations that are just too specialized to justify adding to the core?
Better error messages. No, I'm kidding. Not really. Like when I used to do my simulation of black hole physics, mostly all of the things that I tend to use that were actually crunching numbers were written in C, C++, or Fortran 77, Jesus. And they were like using Python bindings. So I didn't really miss anything. Actually, what I miss actually is the way to multiply matrices using something that is not a function, but we already have that apparently, is the add operator. So it's fine. The rest of the stuff that I wish exists nowadays in third-party libraries, all the GPU accelerated code now is super easy to write. Before it was just insanity. So I will say no. Everything I needed is now here, or it was in the time. But thanks for the question.
For everyone, what feature in 3.11 are you most excited about?
Like actual feature in the language, I'd say better error messages.
Yeah,
me too.
Well, task groups for async.io. Like, I used to do like videos about like async.io for HDB when I worked for them like 2 years back, and that series was not finished. And like one reason why is that like the last planned episode was literally like, hey, how do you do error handling in async.io? And the answer was like, like it wasn't very easy. And with task groups, it's gonna be like the happy case is gonna be much easier. So yeah, that is extra exciting. That is super exciting.
How about you, Irit?
I think in terms of, probably the largest impact will be from the improved error messages and Tracebacks, because a lot of people will notice it and benefit from it very quickly. I think the most innovative new feature is probably accept star, in terms of kind of nobody else has done it before.
Right.
It's an interesting bar.
You're muted, Mark. We will never know.
If I'm going to be sensible, I'm going to say the better error messages. If I'm not being sensible, I'll say
I won. Every time we have asked Mark this question in the past, he always says the speed over the error messages. But now with the pressure,
speed isn't a language feature, though. Oh yeah, if you count speed, then obviously that. But I was actually going to say the infinite recursion.
Right, yeah. It's secret.
Not anymore, it isn't.
Wow.
Nice. Well, it was short, but I hear you say error messages. Best feature. I want to just edit this clip and just cut the part when you say my best feature is error messages, and I will post it everywhere.
I think Lemon was trying to create a mud fight and failed miserably because we're such a friendly bunch.
Yeah, that was my intention. So I think that was our last question. Although we were promised some cat pictures.
I mean, I have 4 cats. I've had more in the past, but this is my large cat Akio, who is about 2 or 3 times as big as normal cats. And then I have these 3 other cats, Kaya, Jamila, and then Dami is the last one. And Dami is very shy. She's afraid of humans for the most part because she came from someone who was evicted with like 50 cats in a very small apartment. And the only cat she really loves is Akio, so she cuddles with him a lot. And then just to show the size difference, the big cat is Akio and the little one is Jamila, who's a normal sized cat. So, and then this is how cute Dami and Akio are together.
Oh.
And
We still need a banana for scale for Akio.
well, you wouldn't be able to see the banana.
I think they lied to you. It's a tiger. You got a tiger.
This was him as a kitten. Let's see if that actually works.
A
Yeah.
cheetah.
He is very, very busy, and apparently while we were doing the stream, I'm not at home, I'm in California visiting for work, but while we were doing the stream, he tossed a 2-kilogram jar off a shelf in protest
Wow.
back home. So
I think this video is very representative of doing a release.
On topic.
Nice. That's some pretty high quality photography.
um,
Did you take those pictures?
most of them were taken by my wife. The videos were taken by me. In fact, the pictures, apart from 2 of them, the pictures were all taken by my wife while I was here, just to remind me what I'm missing back home. And she is a semi-professional photographer.
Yeah, that makes sense.
Yeah.
She's clearly good at it. That's great. That's a nice note to end the stream on, I think. So with that, I would like to thank you all for coming on here.
Well, thank you all and the team for the hard work. I know that managing these things is not easy, and this was an excellent stream with all the questions and all that stuff. So from us, thank you a lot for all the work that goes into this and for having us with you one more year.
Yes, I'll be very happy to do it again. If Thomas, if you want to do this kind of thing next year, you just hit me up and we'll make it happen.
I'll make it part of the release process.
Special thanks to
Pep
our,
101 official.
No, you need to stream it.
No, you
Yeah,
need to
yeah,
add it to
yeah,
your
Pep
script,
101.
basically, where it launches a live stream. As
Yeah,
it's
all
running.
the OBS stuff, and it automates all the stuff.
Excellent. I also want to give a special shout out to our event lead, Janine. She's been running the show behind the scenes, doing an excellent job. So she's Cat J9 on the Python Discord server. Give her a shout.
Thank you.
There she is. All right, okay.
Thank you
Well,
all.
Thank you all.
Bye bye. Enjoy
Bye.
Python 3.11. The best version.
Go download.